Hello, Globebusters. Yes, of course they're serious. You do? You have? No kidding. Uh-huh. Oh, they'll cure your globitis this week. Thank you. We got one!
Ladies and gentlemen, it's the Globebusters.
What are you supposed to be, some kind of a cosmonaut?
No, we're exterminators.
And now, here's your host.
And welcome everybody to Globebusters, the lies behind LIGO. I am your host, Bob Xanadude60, and we are back with another Wednesday night show for you. And tonight we're going to be talking about a few different things, but primarily about the very aptly named facility that NASA has run called LIGO. And we've actually covered this before. It's been, gosh, about 3 years at least, 3 or 4 years maybe. So it's been quite some time since we've done that. And so I wanted to cover it again because this is one of those things that it's just a little bit too hard to believe. In fact, it's just utter nonsense. So yeah, so I wanted to cover that, and we're going to go over that and a few other things. You're going to learn a little bit more about laser interferometry, which of course is a technology that's been around for, over 100 years. And it is in fact the very technology that proved the existence of the ether with the Sagnac effect. Now, one of the things that I got to tell you guys about the ether is that the ether was abolished mathematically because of the results of the Michelson-Morley experiment that basically showed that the Earth was not going around the sun. And of course, we're going to get into all that in detail. But unfortunately, Einstein, when he mathematically then abolished the ether, it virtually wrecked his theory of relativity and special relativity. Of course, it was kind of a train wreck anyway, and every other physicist of the time actually knew that. But, it just kind of went downhill from then. Now, what they came up with in substitution of, I should say, etheric physics, was what we know today as quantum physics. And of course, quantum physics, by its very name, implies quantum counting, right? In other words, it's bean counting, as Theoria Apophysis or Ken Wheeler puts it. And they are operating under the assumption that everything in existence is made from smaller and smaller and smaller particles, right? And they completely get away from the idea that anything is manifested out of the ether, because if you guys listen to the show on Sunday and a few other shows that we've talked about, the real nature of reality, at least the ones that we believe in, and we also believe that there is massive scientific evidence to prove it, is that manifestation of all physicalness comes from the ether. And it is a cymatic process that is brought forward through vibration and frequency, and it is exactly how everything is created, and there is just an enormous amount of evidence to back all this up. So unfortunately, there are people in this community that do believe in quantum physics, and that's unfortunate because it really is a sham. Things do not get smaller and smaller and smaller into particles and down to electrons and protons and stuff like that. It's really quite a bit different. Of course, we are teaching the complete alternative to that. And, that alternative theory, before quantum came out, was more of a classical physics. And this is when science was making fantastic leaps and bounds And in fact, as we're finding out today, people back in the 18th, 19th century, it appears that they had free energy, free power. They had all kinds of technology that we didn't have. And, our keepers today simply want us to believe that, we have gone so far beyond that, and that, people 100, 200 years ago were in the Stone Age. They, they didn't have their PCs or their Macs. Therefore, they were, completely in the Stone Age, when in reality it was a far, far different type of society. And that proof is coming out, I think, to a large degree, these days. So that's why we like to talk about it. So anyway, so I'm going to go ahead and let's get the staff introduced today for the show, and then we will move forward with this idea. And one thing I wanted to point out, the video that you're seeing that we are playing right now with the CC on is Physics Girl, or Diana Cowan. And she has I believe a master's degree at MIT, from MIT. And, she's got a fairly popular YouTube channel, but she talks about her experiences in LIGO and, gives some of the technical breakdown. And of course, we're going to be using her description and her interactions with it to basically debunk it as if we needed it. But, it just makes it a little more fun that way. So anyway, let's go ahead and introduce the panel. First up, we have John the Morgile. How you doing today, John? Oops. You there, John?
Doing very well. I'm here doing very well, Bob. Thanks for asking. Hope you're doing well.
Yeah, doing fantastic. All right. Excellent. Also with us today, we have John Savage. How you doing, John?
I'm doing very well, Bob, despite what's going on in our world over here. Still in prison Britain, but yeah, looking forward to the show, and cheers for the invite.
Awesome. Glad to hear it. Yeah, I know it's getting crazy back there, and we revealed some information on Sunday's show that was not real positive, but that's just something we can't talk about on the YouTube side of it, so we won't. But yeah, it's unfortunate that this is happening, but it is what it is. So we just have to make the best of it.
Yeah, so, what doesn't kill you makes you stronger.
Yeah, exactly. And as all of you may remember, on Sunday, we actually introduced a new globe buster to the team. He's not with us tonight. He actually had to work out some issues with his employer to get the scheduling so that he could be with us on the Wednesday show. So he's handling that with his employer, and that, of course, is the Great Baldini. But in addition to the Great Baldini, we've also brought on as a full-time globebuster the Good Times for All channel, or Zachary Zabala, if you prefer. And Zach is with us now. How you doing today, Zach?
Hey, Bob, doing well. Yeah, thanks so much, man. It's very humbling. It's an honor to be a part of the team. So yeah, thank you so much.
Yeah, you're very welcome. And Zach, if you guys are not familiar with Zach's work and Good Times for All, check out his channel, because Zach is gifted with being able to make very nice and outstanding videos. And so the great thing about having Zach around is I can communicate my thoughts and my ideas to him, and we will kind of bounce things off of each other. And then he will take those thoughts and ideas, and he'll take them and make them into videos. And, some of his videos have been absolutely fantastic, demonstrating the electrostatic effects on, what we're calling gravity, the downward accelerative type of effects, how that actually works. It's a brilliant alternative model to the silly one that, Einstein would have you believe, the bendy space-time, or even the matter attracting matter from Newtonian type of physics. But, this is really, the way that things are going. Like I said, the truths are being revealed all over the place, and physics is absolutely going in that direction. And that's, of course, why we have so many trolls that are out there pushing this alternative method of physics, and it's just nonsense. But, you just have to deal with it, because change does seem to come hard. So there you have it. All right. So I think that introduces the whole panel. So, all right. So first of all, if you have been listening or watching this particular video, the first thing that we see is that she is here at the LIGO. I believe this is the Livingston, Louisiana facility. And one thing I want you to notice is that one thing she will tell you here in just a little bit is that this facility has these two 4-kilometer legs, and so does the one in Hanford, Washington, right? And so what they've done is in these 4-kilometer legs, they have these aluminum or steel. I think there might be steel. It's like 1/8-inch steel, very, very thin steel, right? That they shoot these lasers through. And what's crazy about it, and the first thing that I noticed is that she says that they put a complete vacuum in there. Now, she doesn't actually give a figure of what that vacuum is, but if you guys have, heard me talk about the facilities that NASA has, about their vacuum, chamber testing, we know that those facilities have 8-foot thick concrete walls with steel lining in them to stop the air from being literally drawn through the concrete. And, obviously structurally, when you get down to a negative 10 to the 6 torr, 10 to the negative 6 torr, you are generating quite a bit of vacuum. And of course, when you look at these little bitty, ridiculous, 1/8-inch steel tubes that they shoot this, it's ridiculous to even think that they could put any sort of vacuum in there that would make a whole lot of difference. But whatever. But that is one thing that she does, talk about, that she's in there. And I just thought that was ridiculous, because that is really, really, really thin. So, all right.
Yeah, looking at those videos of the what are they? The train, compressed air train,
the tanker
carriages.
cars. Yep.
Yeah, the way they. I mean, yeah, that's pretty crazy.
Mm-hmm. Yeah, it is. So anyway, well, you know what? Let's just go ahead and cut into her audio here, and let's let her describe a little bit of this, her trip, and we'll just kind of make a commentary about it, because this is kind of what I want to do, is take this apart piece by piece. So let's listen to Miss Diana Cowan of Physics Scroll channel, and this is for fair use.
Through us all the time. It turns out space-time can stretch like a slinky and can carry waves across the universe.
Which of course is bullshit.
We don't know when we're going to discover gravitational waves. It could be in the next 10 years, it could be in the next 50. We don't know if this detector is going to work. And then when the announcement was made in 2015, which was only like 4 years after I graduated, I was like, what? No.
That's so cool.
Gravity is cool. It's also weird. It doesn't affect space instantaneously. If the sun suddenly disappeared, poof, the Earth would continue on orbiting as if the sun were still there for 8 minutes and 20 more seconds until that information about the change in the gravitational field would get to us. And then Earth would fly off into space. But at that—
Yeah, so what she's saying, guys, is that, first of all, gravity is acting like the speed of light, right?
Yeah, that's exactly what she's saying. Where does she get that from?
That's really hard to say, because NASA does not do that. When NASA does their calculations on solar system orbital dynamics, it is under the assumption that it is instantaneous. And I have checked this multiple times, and anybody says that they're actually calculating, based on this 186,282 mile per second gravitational effect is full of it, because they just don't do it that way. So it's pretty laughable, first of all. And of course, that used to be the norm. And then all of a sudden they decided to start changing the narrative. But of course, that's what they're doing more and more as we, start tearing them and their lives apart. So anyway, let's continue listening on to her and see what else she has to say.
that same instant, light would reach us too, and we would see that the sun is gone. But you know what that means? The speed of gravity and the speed of light are the same. That's one of the many things that we've confirmed down to the order of 10 to the minus 15 from the detection of gravitational waves. And those giant...
Okay, now first of all, she says that's one of the many things that we have confirmed down to the detection of gravitational waves. Now guys, first of all, the detection of gravitational waves only happened theoretically, and this was a load of crap too, about 3-4 years ago, something like that, when two black holes came together, spiraled together a long time ago in a galaxy far, far away. The two black holes spiraled together, and the distance of this galaxy, get this guys, is 450 billion light years away. just let that cook in your head for a minute, right?
I thought it was
they
1.2 billion. Wasn't it 1.2 billion or?
No, it's 450 billion light years away. The two big ones.
Me?
Yep.
Oh my.
Do they claim to be able to see that far with any of our telescopes?
Well,
450 billion light years. That's
not optically, obviously. So what they're doing is they're doing it with radio astronomy. So, and how that works, I don't know, because how, and again, we've talked about this. I'm sorry, but radio waves just do not travel for 450 billion light years, nor do we have the capability of receiving anyway. It's just nonsense, okay? But this is the story, that's the story, is that 450 billion light years away from here, these two gravitational or black holes came together and they collided. And when they collided, right, they then generated the one and only gravitational wave that they've ever been able to measure, right? Because, mind you, we have never had the capability to measure any gravitational wave, right? If we would have, we should have been able to, put one of them LIGO detectors underneath the moon, right? And when the moon passed over, we should see the LIGO go crazy, right? Well, no, it doesn't. Nope, sorry, it doesn't work that way. The LIGO picks up nothing. And of course, the moon is said to have such a heavy gravitational field that it is able to pick up trillions of tons of water and, cause the tides, and the story, right? It's nonsense. So anyway, 450 billion years later, which happened to be on the exact day of the 100th anniversary of the day that Einstein predicted black holes, what a coincidence that would happen, right? It's amazing.
Good grief.
Wait, how old did they say the universe is? Is it even 450 billion years old?
No, not billion, million. Did I say billion?
Or million?
A million. Yeah, if I said billion, I apologize. It's 450 million light years.
That in there. Yeah,
okay.
Okay. It doesn't make sense, but okay.
Yeah.
Oh, well, that's completely different, Bob. I mean,
yeah, I know, right? It's all the difference in the world, right?
That's in the neighborhood, isn't that? Just about as far away as the North Star?
Yeah. But yes, no, if I said billion, I apologize. It was 450 million light years away. So, or wait a minute. God, you know what? Now I'm completely confused.
I'm pretty sure, because I remember when they did the press conference for LIGO, they claimed that it was 1.2 billion years ago, and therefore it was 1.2 billion light years away, is what they claimed. I'm almost positive.
Well, that's even a hell of a lot more than 450 million.
Yeah.
Oh, you know what I'm thinking of? A 450 million is I'm thinking the distance to Polaris.
There you go.
Which is, of course, also nonsense.
It's all, it doesn't make a difference exactly how full of shit they are.
Yeah, totally. Anyway, she's got 2 videos here we're going to go through, and she'll spit out the exact number. So I apologize if I got it wrong, but whatever it is, it's still so ridiculous. It's just off the chart laughable. So, all right. So let's go ahead and continue on and listen to her. Here we go.
Gravitational field would get to us, and then Earth would fly off into space. But at that same instant, light would reach us too, and we would see that the sun is gone. But you know what that means? The speed of gravity and the speed of light are the same. That's one of the many things that we've confirmed down to the order of 10 to the minus 15 from the detection of gravitational waves. And those giant...
Right, and so my whole point is if it had only been detected 3-4 years ago that these waves even really existed, and it was all theoretical beforehand because they've never been able to measure a gravitational field or even tell us where there is one or how it can be detected, then how is it that they have confirmed this right down to, the exact, to 186,282 miles per second? How could they have done this? Of course, it's complete nonsense.
In the model, Bob. In the model. Everything these days, we assume now that we live in a model, so they can just model it away like COVID.
It seems to me really that they did the whole LIGO thing in response to flat earthers, because this was a huge point of contention that There was no experimental evidence for gravity. It was still in the realm of theory. It was merely theoretical, and it was I want to say 2015 or 2016 when they came out with this news that the whole gravitational wave thing, and it really was timely that now the globe Earth proponents can say, see, there is experimental evidence for gravity, but there isn't. It's just it's so frustrating. But I believe it was just in response to flat earthers because they had no sort of experimental foundation for gravity.
Yeah, I agree. I agree.
And this is one of those experiments that no flat earther can duplicate.
Mm-hmm.
We can't go build a 2-mile long, straight facility underground with all this stuff that they're doing. Nobody else can do this. So this is the same as the priest coming out of the temple in the olden days, the temple you couldn't walk into because you would die right away, right? That's what you're told. So him coming out and telling you and just saying you have to take my word for it because you can't go in the temple.
Yeah. Well, it just means that we don't need to build a 2-mile long tunnel and spout all this nonsense. We actually can work it out for ourselves logically.
That's right. We don't need no stinking badges. So, all right. Let's continue on and keep taking this apart.
Concrete tunnels, those are the exoskeleton of 2 giant arms of the first gravitational wave detector, LIGO. Gravitational wave detectors have to be huge because they need to detect waves coming from billions of light years away. They're so sensitive that trucks nearby affect the signal. When we were there, they told us to accelerate and decelerate slowly so as not to disturb the detector. And also, the AC unit is not even connected to the building. They had to put it in a separate enclosure on springs so that it wouldn't mess with the signal. And then there's this.
Okay, now before we go to that, this is a load of horse manure, at 10 to the 18th power, okay? So they're sitting there saying, oh, you got to tiptoe around, drive slowly, got to put the air conditioner on springs because otherwise you're going to set off our LIGO unit. And then at some point in here, she's also going to say, yeah, you can't be around anything that makes any noise or anything like that. You can't have any earthquakes or anything like that because it'll set this off. So what did they do? Well, let me show you what they did. LIGO, at least the Livingston, Louisiana facility, is right next, or actually right in the midst of, I should say, 3 major faults. Okay, they are the Scotlandville, the Denham Springs, and the Baton Rouge faults. Right. This place is an earthquake hotbed, like big time. Okay. There's
just where you'd put it, eh?
Yes, and Livingston is right there. I mean, within 20 miles of all of these other cities, right? I mean, it's right in the middle of it. 3 major fault lines. That's like, yeah, why don't we just go ahead and build the other one on the San Andreas Fault, See, I'm telling you. So, but yeah, and it's interesting because this information, it's not like it was hard to find at all, But
like lorries can upset this thing, driving by, but the moon has no effect whatsoever. It's amazing.
Exactly. Yeah, you have to, anything that could, you got to tiptoe. You don't want to, have any flies farting or anything like that. It's just utterly ridiculous. And yet they build it on the intersection, quite literally, of 3 major fault lines. Wow. I mean, who was the engineer that thought that one up? You got to wonder. All right. So let's go back. That's point number 1 annihilated. That's pretty damn funny. And here we go.
Those liquid nitrogen tanks have tubes that go inside that carry the liquid nitrogen inside.
Yeah.
And they were getting ice around those tubes.
Yeah.
And the ravens were coming out and pecking at that.
Oh my gosh.
And that little bit of vibration coupled back into the interferometer.
But that insane sensitivity allowed us to detect an entirely new type of phenomenon. I should tell you how the detector works.
So this is like a cross-section of what the cement tunnel would look like.
This is one of the sections of the concrete structure, the beam tube cover.
The concrete tunnels house 2 4-kilometer long tubes made of metal that are actually under vacuum, which is surprising because the metal is pretty thin.
Yep. See, even she notices that, right? It is thin. I mean, it looks like it's 1/8 inch steel. which is nowhere near thick enough to house any 10 to the negative anything vacuum. We've seen.
Do they state the power of the vacuum? Because any pressure differential is technically a vacuum, isn't it? Or
yes, but they do not. And I did look for that, but that information was, I wasn't able to find it. Perhaps somebody will be able to find it and link it in the description. But the crazy thing about it is, I did a Glowbusters show a few years ago where we were talking about the power of vacuums, right? And it was, of course, in response to NASA's vacuum facility in Sandusky, Ohio, right? Their vacuum, whatever it is they call it. And we're just sitting there in awe of the structural strength that this facility had to have. Like I said, 8-foot concrete and steel thick walls, right? In order to be able to maintain a 10 to the negative 6 torr. And yet, then I pulled up a nifty little vacuum, a nifty little video that showed, maybe it was Mythbusters or somebody, that were able to take an ordinary shop vac, right? Just the vacuum that an ordinary shop vac can create, or I should say pressure differential, and it was able to lift up a 2-ton car. Do you remember that, John, on that show?
I do.
Yeah. Okay. Yeah.
I don't remember that part. Sorry. Yeah, no, I don't remember that specifically, but I do remember the show that we did on vacuums. And yeah, I would love to know, exactly how they got these tubes to such a complete, air quotes, complete vacuum, and how they did that structurally and what power vacuum they had. You'd think that would be published information because this is a tax-funded project, right?
Yeah.
But they are kind of secretive.
I reckon they're just saying it to sound sciencey. They've probably got an extractor fan from a toilet running at one end of the tube, and that technically is a vacuum. So,
they couldn't get around diffraction with the nitrogen-oxygen-based atmosphere. They had to lower that and try to make it, get as much atmosphere out of the way. So there was none of the diffraction you get from that straight optics.
Yeah, exactly. And by the way, John, those toilet extractor fans, we call those instinkerators here. So there you have it. There's a technical name for it. All right, so let's continue on here.
Is the section of the beam tube itself.
Gotcha. So that is holding the vacuum. Whoa.
A powerful laser is shot out and split into 2 beams, and each is sent off into the X and Y arms of the detector. That's what they call them. Then, depending on the distance those laser beams travel, when they meet back up again, the waves add and they interfere and make patterns, like waves that overlap in water making patterns. If space is stretched or squeezed in one of the directions by passing gravitational waves, the laser beam in that arm will travel a shorter or longer distance, affecting how the 2 beams, add up when they're recombined. And we can tell space has been stretched by a gravitational wave.
We're trying to do everything possible.
Okay, now mind you, like I said, no other gravitational wave has ever been detected, or they would have been able to use the moon passing overhead, or even the orbit around the sun for gravitational changes to be able to at least calibrate LIGO, right? Well, sorry, no such luck. That's, there is no information whatsoever on any type of wave detection like that. And again, like I said, mainstream science tells us point blank that the moon is drawing the oceans up, trillions of tons of water. Man, that is one strong freaking wave. Right?
and how did they calculate how far away it was from a wave? I don't understand. That's
a good question. If it took 4 point or however many billion years it was to get here, and that will be in one of these videos, I don't know. I honestly do not know how they could even calculate that, because basically you have an open-ended equation, right? You have something that you see on the result side, but you have no other information to lead you to be able to solve the rest of the equation. And so this must be some serious mathematics. Yeah.
Much like every other light in the sky, we have more information to be able to make those sort of calculations. Sorry, John.
Oh, no, you're fine. And it is a good point. I mean, how did you calibrate something like that? You would think that they would use something regular, like, the moon crossing over, which we already know, right, in air quotes, we already know that there's the tides that are allegedly caused by the moon, and that happens regularly. And so you would think that you would calibrate such a device for detecting gravitational waves with something regular that is there. But then for them to come out of left field saying that they got this signal, and the information that they use to make these very, very bold claims is pretty laughable, and I'm sure we'll get to that. But it's a good point. I mean, how do you calibrate that? What are you comparing that to? You know what I mean? It is pretty confusing, or it's a conundrum. How are they doing this? I would love to know.
And also, how can she say with certainty that they know for a fact that it's gravitational waves that are causing it, when they obviously had birds pecking on the side of the building? I mean, that must have taken a good couple of weeks to realize that it was birds pecking on the side of a building.
I have the answer to that question, John. That one I can answer. All right, here's how. Because these facilities, and there's also other gravitational facilities, there's a Virgo facility, and there's a couple other ones, I can't remember exactly what they're called, but they work in tandem. And essentially what happens is the theory is that when the gravitational wave comes in, it hits both locations pretty much simultaneously, right? Because, after billions of light years, what's a couple thousand miles between Hanford, Washington, and, Louisiana?
It's the difference between winter and summer, Bob. Yeah,
right.
Sorry. Yeah, no, I get it. Yeah.
So basically what would happen is that they would have to have the same phase, the same interference pattern, right? The same phase shift on both facilities at the same time, and that would constitute a positive hit, right? Now, the interesting thing about this, guys, is the first time they did this, right around the 100th anniversary of Einstein's birthday, is they had a supervisor that was in there, and they had this little, to test their staff, right? They had a little button installed where he could hit the button and it would give them a false positive. And so he did that. And this is how the story goes, right? He did that. Hanford, Washington, and Louisiana both got, positives. They both called up the press and said, guess what? We got gravitational waves. And then they wound up having to retract it until a few days or weeks or months later. And then they got their real one, right? Yeah, fortunately. Yeah,
right. So really, the answer is that a bunch of club members with equipment that nobody else has all work in conjunction to come up with something and prove that it exists over all of us peons. Gotcha.
Yeah, exactly.
Never happened before. No, what could possibly go wrong?
Yeah, exactly. All right, let's continue.
Possible to keep any particulates out.
We're just hairnet and shoe covers. We're going into the experiment hall. From what I remember, because I've been here before, this is the laser. That enclosure over there is the laser.
Absolutely.
That infrared laser beam comes out of that big building thing over there and through here, and then this is where it splits into the two beams.
And then when they come back and they merge here as well. So down this way we come to where we've got
The photodiodes.
This is where the gravitational wave signal is
Detected.
detected, yeah.
That was the photodiode that detected the actual first gravitational wave. And I got to hold it, kind of. I got close to it. Wow. They told me not to touch it. Wow. Now the next thing to consider is where to put one of these detectors. You can't just put it anywhere. They have to be far away from earthquakes or people because they move.
Well, they blew that one, didn't they? Right? We already covered the 3 fault lines. So let's keep going.
Move too much. Some people can't stop moving.
Like, why wouldn't they put something like that in like Siberia or something? Like just out in the middle of nowhere.
Yeah, exactly. And again, the whole idea, if they have woodpeckers that are setting that thing off, right? I mean, come on, the wind would do it. Being on 3 fault lines, of course, tremors are going to do that. But again, their fallback is as well, if we don't have that simultaneous phase shift with the Hanford, Washington, then it's business as usual, right? But here's the thing.
even a broken clock is right twice a day, right? I mean, eventually it's going to happen just by sheer chance, right? I mean, you would think.
You would think, but here's the thing. First of all, when they are saying they are hypothesizing, right? This is pure conjecture that any so-called gravitational wave, when it passes through a laser interferometer, tube or one of those arms, that it literally, and I get this, what supposedly happens when it does this is that when the gravitational wave goes through the arm of the laser interferometer, it reduces the length of the arm by the width of a proton. Okay? So not only do you have 4 kilometers, right? You have 4 kilometers of length, but then they also shoot it back and forth. So it's several kilometers, right? Maybe 10,000. Anyway, they say it several thousand kilometers, right? Because they go back and forth and back and forth and back and forth and back and forth, right? So again, it supposedly changes that by the width of a proton, which we can't even visualize a proton or measure it or anything like that, again, but they have to give us these, particle physics, because that's all they have, right? They cannot go to any other reference, because remember, Einstein got rid of the ether, and so things cannot be vibrated into form, which we know damn well that they can, and cymatics proves it, and so did the luminiferous ether. But I digress. All right.
I just can't believe people of intelligence are buying this crap.
It's beyond belief, John. Oh my God. Yeah. It's like you have a doctorate in physics and you buy this crap? Whoa.
Maybe that must be the problem, isn't it? Is that they have invested so much of their life into this crap that they have to believe it. Good grief.
Yeah, it's nuts. All right, let's continue.
They're going through the air.
And it's like at the beginning of the show. Oh, sorry.
That's all right.
At the beginning of the show, you had mentioned the Michelson-Morley data disproved the Earth going around the sun, and yet that information, that data, is just disregarded because we live in a world where anti-science or pseudoscience rules the day. Any information that flies in the face or discredits the theory that the Earth is a ball going around the sun is just ignored, and it is rejected. And that people are fine with that. And of course, that is anti-science. That's pseudoscience. I mean, to reject data that doesn't conform to your belief, and cherry picking data that we want to use and disregarding data that we don't want to use, that's the opposite of science, isn't it?
Yeah, no, totally. And it's like you said earlier, Bob, that so many intelligent, scientifically minded people around Einstein called him out on this bullshit. You can still find papers that are destroying Einstein back in the day, but look what they've done and how they manipulated history so that we now worship gods like Einstein and Churchill and things like this, when the absolute opposite is true, or should be true.
Yeah, it is crazy.
Einstein, I don't remember many famous scientists learning about them back in the day. I remember Alexander Graham Bell, Thomas Jefferson, or what's his name? Edison, and Albert Einstein.
Yeah.
And these were all nothing of Cavendish, nothing of Michelson-Morley, Sagnac, none of these things. Airy's failure. Didn't hear about any of these tests that were done.
No,
and Einstein didn't do any tests. None,
neither did did several graduate physics students, Zack, and we're actually going to cover that because in a letter that Malcolm Bowden received, and this is something that is absolutely true. They do not teach graduate students about these particular laser interferometry experiments because they kill the idea of, they do two things. They completely annihilate quantum physics, in its entirety, and they also prove then, moving backwards, that the Earth is not moving. And beyond that, they also prove that the ether is there. And beyond that, they also prove that things do become manifest, just like the Bible says. Imagine that, through some sort of vibrational stimulation, And this is all stuff, guys, that we can demonstrate. We can actually go in a lab and demonstrate it. Nothing that they say can be demonstrated. Not one iota of it.
Well, they do prove that they do teach the laser interferometry stuff, because that's essentially what LIGO is, isn't it? It's a mass mock-up of Sagnac's experiment.
It's exactly what it is.
But only when it proves, or only when they can put their own spin on it. If they told people that you could spin something on a kitchen table and work it out for yourself, then rather than having to build miles of tubing and have vacuums and all this nonsense they're talking about. So, yeah, they'll only teach it with their own spin on it, and you can't go and prove it otherwise. So there.
Yeah, that's exactly right. All right, let's continue on. And we will be covering also those particular experiments. So we'll get to that here shortly. Here we go.
Noise and just the gas in the atmosphere. So the tubes of the detector arms are completely evacuated of everything. Plus there are other crazy considerations.
I doubt that.
The tunnels are so long that they have to correct for the curvature of Earth.
Over 4 kilometers.
Oh boy, all right. All right, when she said that, I mean, not only do I know that's bullshit, right? But think about that for a minute. So they go back and forth several times, so it's actually more like maybe hundreds of kilometers. They say it in this somewhere. But you got to think about that for a second. First of all, why would they correct for the curvature of the Earth, right? Why would they want that to, bend along with the curvature of the Earth, or bend away from it? They're not very specific on what they're saying there. But if they're saying that they had to do anything other than simply, get a surveyor out there and make sure that it was level, then they must be saying that they are making special allowances for that 8 inches per mile curvature, right? And then bending the tube accordingly, right? That's how I read it.
I don't think so. I think it's the opposite of that. I think it would be they would make sure that it's not level, because there's a laser beam going through there, right? And
yes,
the laser beam would have to go straight, and so that thing would be essentially a tangent to the curve, I would think.
Right. So exactly, that's the point, John. And so what they would have to do then is, since they would have to go under the assumption that the Earth is curving, then they would have to literally have the pipe rise up off of the ground, right? To keep a straight line. Now, here's the problem with that. It's like, they would do that because obviously the laser would not succumb to gravitational effects. The gravity isn't going to pull the laser down. Sorry, guys. Not going to happen, not in, so-called Earth gravity. So, that just raises all kinds of questions.
What she's saying is that it's not level.
It's exactly what she...
At the center, it's level, but at the edges...
It's got a bow in it.
It's not level. Yeah.
So when it bounces back and forth and back and forth and back and forth over a bowed area, how do you think that light is going to respond to that? It's going to be a complete mess. How is that beam going to stay linear going back and forth if they built a big old arc into the middle of that thing for curvature? That's a problem.
How would they know if it's going back and forth so many times? How do they know that the two beams they're picking up are the two beams that are in that cycle? What if they're picking up beams from multiple, different cycles?
There's sensors, and you can actually, see the sensors and the timing of the beams hitting it. And that goes beyond a little bit, but it is possible. Let's put it that way. But their
claim is that laser beams and radio waves and everything adhere to the curvature of the Earth. So why would they need to correct for the curvature of the Earth?
Well, that's the thing. And if they correct for the curvature of the Earth, they've screwed up the environment inside of the tubes.
And
right?
they've just verified that laser beams travel in straight lines, and so do radio waves and everything else. Well,
especially in a vacuum, because in a vacuum there's no refraction, so it cannot draw the laser beam in any direction. And they're also then conceding then that the Earth's gravity would not have an effect on the laser beam. I guess I don't think that they would have a problem conceding that anyway, but you never know with these ballers, you know, something may require that, you know, concession to be withdrawn, and they will do so if it's necessary. So
And,
let's
and
continue.
once again, this woman can spew this nonsense without even a thought, without even sitting there going, hold on a minute.
Yeah, because she's pretty and she's got a master's from MIT.
There you go.
Well, I would love to know what exactly she means by correct for the curvature, because I'm pretty sure that this interferometer device, the tube is straight throughout the 4 miles or whatever. And
I would agree with that.
By correct for the curvature, I don't think she means that it's bowed out. I think she means that it is not level, which I'm pretty sure you could walk the length of that thing and it's level all the way across. So wow.
Exactly, which means that nobody corrected for anything. Right? That would mean that nobody corrected for anything. Right. Let's continue.
Kilometers, the Earth drops about 1.5 meters.
The detector is so sensitive, it's affected by quantum fluctuations, which is essentially randomness caused by quantum mechanics in the mirrors. Some of the problems.
Yeah, John, I believe your comment on that last time was if a gnat farted, it would set it off. And that still stands, man. Let's continue.
And she said, did you notice, she said 1.5 meters it would drop.
Yeah, it's crazy.
Noise are solved by having an identical detector nearly 2,000 miles away doing the exact same thing. There's another LIGO in Livingston, Louisiana, and when a gravitational wave passes through both detectors, the signals line up perfectly. And one more thing, both detectors have 4-kilometer long arms, but they're actually effectively 1,200 kilometers.
There we go.
And the light bounces back and forth on average about 300 times. So that makes the arm length not just 4 kilometers, but effectively 1,200 kilometers long.
That's crazy.
And length matters here. You need the longer the arm, the larger the overall effect that the gravitational wave has on the arms.
You know a clever way to get an even bigger detector? Put it in space. This is a real plan. I was like, how are they going to launch vacuum tubes long enough up into space? Isn't that hard? And then they politely reminded me that space is a vacuum. Excellent point, space scientists.
Derp.
Now, what kinds of things do you see with these detectors? Oh,
And
just
she
simple violent
graduated from
events like
MIT?
Yeah. Oh, I forgot.
Wow.
Space is a vacuum.
Where do I sign up?
Yeah.
Ay, caramba.
neutron stars smashing into each other. The first detection was 2 giant, enormous black holes colliding 1.3 billion light years away.
Ah, you're right, John. 1.3 billion light years away.
You can tell from the waves on the ring down that this thing was 62 solar mass.
So I was only off, I said 450 million, so I was only off by, 300%. So yeah, that's close enough, right? For government work.
If you're in science, if you're doing science,
yeah,
it's close enough.
But no, John was right on the money at 1.3 bill. Okay, let's go.
So in that process, 3 times the mass of the sun were converted into gravitational wave energy.
Yeah.
At the time, it was the most powerful astronomical event known to human beings because of that.
And what's funny is they cannot tell us what gravitational wave energy is. They cannot tell us what it is. The only thing they can tell us about gravity, their version of it, is that it accelerates things at 9.8 meters per second squared, right? That's all they can tell us.
On Earth.
On Earth, yeah. And the rest of it is complete fairy tales. Oops.
Well, and it's so funny.
Go ahead.
Well, because the graphic that they just, there was like an animation that they just played where it looked like, I don't know, your kitchen sink draining or a toilet flushing with stars behind it. That is a real computer simulation, if you can believe it.
Genuine imitation of a real simulation.
Yeah, a genuine simulation, yeah.
Let's go.
Times the mass of the sun in a quarter second. That outshines all the stars in the known universe for that quarter second. None of it's coming out in light. It's all coming out in gravitational waves. That makes it this super exotic.
Yeah,
object,
but they have no idea what a gravitational wave is.
And measure the gravitational waves there. It's still a paltry amount.
So to them, whatever a gravitational wave is, see, again, they don't say what it is. They will tell you what it does. What does it do? It passes through the arm. It reduces the length, the physical length of one of those arms by the width of a proton after going back and forth for 1,200 kilometers, right? 1,200 kilometers, and then there's a width of a proton detected, and bada bing, that means that it was one really big gravitational event. But again, they can't detect the moon going overhead. You would think that literally if a bird flew over, they should be able to pick that mass up gravitationally with that type of sensitivity. Right? Seriously. But no.
Compared to what you need to actually see them.
You heard him right. A nuclear bomb puts out an insignificant, meager amount of energy compared to what is measurable with gravitational waves. I wonder how many nuclear bombs this actually is. Can you hand me my laptop? Thank you. So it's 3 solar masses, 5 times 10 to the 47th joules versus 2 times 10 to the 10 to the 17th joules. The number of nuclear bombs in this collision, about 2 times 10 to the 30th. That's 2 with 30 zeros.
Yes, and let's not forget that nuclear bombs are also another fairy tale.
Fallacy, yeah. And this is where the education comes from. This is Wikipedia education right there.
Totally. I mean, just because Wiki says it happened and, we're told our story in history class that we dropped a bomb, dropped the A-bomb on Hiroshima and Nagasaki, then it happened, right? But it didn't happen, and it provably didn't happen. Those cities were firebombed, and everything about it was constructed. I mean, even the supposed, the famous shot from outside the Enola Gay window, right? The plane that dropped the bomb, that window doesn't exist on the plane. So that was completely fabricated. Like everything is all fabricated. Absolutely insane. Let's continue.
Fear porn.
Okay. That's not even a number I can fathom. Thank you.
Us either, Diana. Don't
The
worry.
only reason they're so small when they get to us is they've been traveling through the universe for 1 billion years. When they first happened, they were very concentrated here, right?
Yeah.
And as they start radiating outward, they don't attenuate as they go through matter. But as it goes out, you're now covering a bigger volume. The whole wave together would have the same amount of energy.
Right.
But the amplitude has to go down because it's been spread out so much more. So by the time it comes to us 1 billion years after the collision, they're exceedingly small.
One of the reasons that the waves are so small is that space is really, really stiff. It resists being stretched by a lot. It's the stiffest, strongest stuff thing. I'm not really sure what word to use to describe space, but it's the stiffest.
Bullshit, maybe?
Yeah. How about a privation? That would be a good word, Diana, a privation. And a privation is something that you cannot modify, you cannot change. So basically what you're trying to describe is bullshit.
Medium that we know
A lack of substance.
What is
very tough stuff indeed.
Yeah, totally. Yeah, nothingness. And that's it. Well, think about it. When nothing exploded, it made the whole universe. So yeah, that's some pretty amazing stuff, that nothing. Eesh.
In general relativity, is effectively the Young's modulus of space-time.
Yeah.
Which in materials, Young modulus tells you how compressible something is.
Right.
The melting of our brains just thinking about scale alone.
Yeah, no, the melting of your brains happened when you went through university. And that's just fact, Jack. So, all right, so let's go through this one. We're going to go through this one fairly quickly. And then I'm going to actually get into laser interferometry and show you how it works and what we use it for in modern day technology. And as I said, here's the comical part of, the mainstream hypocrisy. And that is that the very same thing that they say doesn't exist, the luminiferous ether, is the very thing that powers, that makes things like the ring laser gyro and the fiber optic gyro possible, because we are able to literally, this is a malleable type of substance, right? We can tell that it's there. It responds. We can detect it. We can manipulate it. All this stuff. The luminiferous ether is absolutely there, and this technology that airliners use all over the world, airliners and private planes, everything. These navigational aids are all using these ring laser and fiber optic gyros, and they work off of the Sagnac effect. And the Sagnac effect absolutely, unequivocally proved beyond any doubt whatsoever that the luminiferous ether exists, because again, it works based on waves, right? Light is a wave. It is not a particle, it's a wave. But more so, it's not that it's a wave, it's what it's doing, because a wave is not something what something is, it's what something does, right? So then you have to ask yourself, what is it that's waving, right? What's oscillating, what's vibrating? Well, the answer to that is the medium. Just like, as we talked about when Baldini was here, you have the air, which is the medium, okay, so to speak, for audio and speakers and stuff like that. When you get into light and you get into electromagnetic radiation, then you have the luminiferous ether is what's actually going through there. And also, it will navigate through water. It does change its rate of induction into that. That's thus the speed of light changes when it goes through water, right? It goes down to about 0.6 C, or about 60% of, what it would go through free space or even a vacuum in, right? So we have all this technology that absolutely operates off the luminiferous ether, and yet people will still tell you that it doesn't exist. And it's like, okay, if it doesn't exist, then how does a fiber optic or ring laser gyro work? What is it waving? What is in there? They can't answer that. They'll never be able to answer that. They can come up with some relativity BS thing, but even that can be debunked. But anyway, I digress. Let's continue on with this second video with Miss Diane Cowan. Again, this one is for fair use as well, for commentary and educational purposes. Here we go.
Studios. Here's a ridiculous idea. Imagine I snapped a twig in an isolated forest. Then
Ridiculous,
a listener on
yes.
the opposite side of the planet hears the sound vibrations created by the snap, and just by hearing it can tell you exactly where I was, at what time I snapped it, and even what kind of tree the twig came from. Of course, this is impossible, but what if I told you that human beings could do something similar, but even more impressive?
Right. So she comes up with an example that is right here on good old plain Earth that she will readily admit is impossible. But then she's turning around and she's going to say, but you know what we can do? We can do that very same thing 1.3 billion light years away. What do you think of them apples?
Yeah, that's even more impossible.
Yeah, it's even more impossible, but we can do that.
But it's a cinch. Simple.
The difference is one you can prove, the other you cannot.
But it's like, I mean, they were saying in the previous video that, the gravitational waves expand out and the entire wave has the same power or whatever, but at individual points it has to diminish. It's like dropping, a tiny pebble in a massive lake and expecting that ripple to reach the shores to be able to be measured. And this is exactly what she's contradicting now by saying that she can snap a twig anywhere in the earth and someone can hear it and work out where it was. And I mean,
exactly.
Am I wrong?
No, you're not. And that's the whole thing, and here's the other thing, we're talking about a gravitational wave, gravity, right? Something that supposedly attracts all kinds of stuff to it. You would think that gravitational wave, as it was traversing through the universe, it'd be drawn all kinds of crap into it. And by the time it got here, it'd be so full of stuff that it would just wipe us out, right?
Yeah.
But
totally.
Since the very nature of what this thing is supposedly, a gravitational wave or an attractive type of wave, which we have no way to measure, no way to categorize, no way to beam count, right? We can't beam count it. Again, all we can do is show what it does, not how it does it. And of course, when you get into the alternative theory of electrostatic attraction that Zack and I have, conferred, and Zack made the video on them, it becomes very clear. And it's quite simple as always. It always is that way. So let's continue on.
Instead of a snapped twig, the source of the vibration is a violent event in space, an event that we can detect here on Earth, even though it occurred billions of light years away and billions of years in the past. All we had to do was build one of the largest and most sensitive devices ever created, the Laser Interferometer Gravitational Wave Observatory, LIGO. I'm driving alongside one of the 4-kilometer-long arms of LIGO, the first ever observatory to observe gravitational waves. The arm is so long that they actually had to correct for the curvature of the Earth. And we're about to go inside to the facility to see all the instrumentation. I am so excited. We're getting on some of our clean room garb. This is a class 10,000 clean room. There's more classes, but this is pretty clean. Yes. Yeah, this is cool.
Why isn't she wearing
So
goggles?
this is like laser starts over there. Then there's mirrors here, beam
And the
splitter,
mask.
laser splits. We've got the arm going this way, another arm going that way.
It's all in this room.
So this is like the brain, the guts, this is everything. Up until extremely recently, astronomy was based almost exclusively on studying light. But LIGO is not like other observatories. It's blind. It senses no part of the electromagnetic spectrum like visible light, microwaves, radio waves. Instead, it detects gravitational waves, which are a completely separate phenomenon from light. In 19...
Oh, really?
Did I just hear that right?
Yeah. I don't even know how I missed that the first time. Let's
Has
play
to be
that
just
again.
Contradiction 101 here.
Oh, man. Let's play that one again.
radio waves. Instead,
Wait, back
it
up a little
detects
bit.
like visible light. It's blind. It senses no part of the electromagnetic spectrum like visible light, microwaves, radio waves. Instead, it detects gravitational waves, which are a completely separate phenomenon from light. In 1916...
Okay, guys. Well, we have a piece of equipment, like I just said, a fiber optic or a ring laser gyro. Let's go with the ring laser gyro because that's actually the closer piece of equipment. And it is not only detecting the light going back and forth and the phase differential of that light, which is electromagnetic, Diana. I'm sorry, sweetheart, but you are wrong. It is all about EM detection. And so what she just said is complete manure. And again, if it detected gravitational waves, you should be able to detect the gravitational pull of the ground, right? You should be able to detect the gravitational pull of the moon. Again, we can't do it. A bird flying over, if it's really that sensitive, it should be able to detect the mass of the bird and the gravitational attraction that that bird would have, because there would be a differentiation between the gravitational pull of the Earth and the gravitational pull of the bird, which admittedly is going to be huge, but we're talking about something that is capable of picking up a gravitational fluctuation from 1.3 billion light years away. Come on, guys.
Yeah, something that happened like before Tyrannosaurus Rex was walking the supposed,
Yeah.
This happened like a
Yeah.
long time ago, and they're saying they can feel it now.
In a galaxy
It's
far,
nonsense.
far away, man.
Yeah.
Let's keep going.
It's like measuring
Isn't that
Tink's
older than
fart
the
from
Earth
Neverland.
itself? Like, how old do they say the Earth is? Yeah.
4.7 billion years or 13.7 billion years or something like that. Yeah. Anyway, older than I'm sure it is, but who knows?
When Albert Einstein published his theory of general relativity, he predicted that masses accelerating in space would create ripples in the fabric of space-time itself. For decades, no one knew if these ripples, called gravitational waves, actually existed. But 99 years later, in 2015, the LIGO team finally sensed a series of extremely tiny vibrations, 1,000th the width of a
99 years later? Nope, it was 100 years, Diana. I think she just didn't want to say 100 years because it literally was to the freaking day. It was on the day, 100 years later, that the detection was made.
proton. To get to that level of sensitivity, they needed to create an observatory that was unlike anything else on Earth. Rather than pointing a mirrored sensor at the stars, they built this L-shaped detector with two 4-kilometer-long vacuum tubes. The arms are covered in concrete, so they're completely protected from all the elements. Then they use lasers and mirrors to detect the compression of gravity, with special suspensions that actively cancel out any vibrations generated from activity on the Earth. And they needed to build two of them, 3,000 kilometers apart, to operate in complete coordination, because a random vibration at one location could create a false signal that looks like a gravitational wave, but isn't.
Yeah, sorry for the redundant content in this, guys, but it does have more filler information that, is fun to debunk. So that's why I'm playing both of these. Let's continue.
Detection is made at both places. You eliminate the possibility of it just being a local disturbance.
The beam splitter itself is in this large chamber right here.
Oh, cool.
But part of the reason why that's so large as well is not just the mirror,
Yeah.
But you've got it in that quad suspension system. And that quad suspension system is really where the magic is in reducing the ground vibrations. Because if you don't reduce those ground vibrations, you don't make detections.
And you have that quad suspension system on
the 4 main mirrors, as well as the beam splitter. Okay. So the 5 largest optics that we have, that is in those suspension systems. Gotcha. We really say every vibration bothers us, and we mean it. From the thermal effects on the mirrors to earthquakes in Australia, they all can cause us problems.
After months of analysis, scientists confirmed that the vibrations detected in 2015 were the signature of 2 black holes merging. It was a violent event that had occurred 1.3 billion light years away and 1.3 billion years in the past. It also confirmed that an entirely new type of astronomy was possible. Wow, so this is it.
Those are where the lasers exit the enclosure area and go directly into the vacuum system.
Wow. There are laser beams going through these tubes?
Yes.
That is very exciting. They're in infrared though, so we would not even be able to see them if there were no protective tubes there, but still. There's this laser beam that comes out and it's a bit messy. It's got different sort of spatial patterns, and they clean it before it gets sent out into the arms. But then you're telling me now that they also clean the input that comes back in, or the output is what you call
absolutely.
it. Yeah.
So you're getting rid of the patterns of the light you don't want.
Right.
And then you do that before it goes in, and you also do that on the way back out. So yeah, the light comes back in, recombines, and then it goes down here for detection.
And then detection happens
down here.
So this part that we're gonna walk up to, this is where the detection happened?
Yeah. I hate to say where the magic happened because the magic happens all over, but this is where the actual detections are made.
This is amazing. You have to see this. The beam makes it here where you've got the detector. That's where the detection happens.
And I actually have the photodiode in my office that saw the first gravitational wave ever, GW150914.
How did you get that?
Well, because I have to put it out.
Okay. So we're putting goggles on to protect from the infrared laser, which you wouldn't be able to see, but you would be able to feel it. LIGO is allowing researchers to explore areas of the universe that were previously hidden because their energy is emitted by objects that are inherently dark, like the collision of black holes. We now know that over millions of pairs of black holes revolve around each other in binary systems. As they orbit, these pairs emit gravitational waves, which removes some of the system's energy and forces the pair to rotate faster and closer together. But because this...
Okay, so what I want to say about this, guys, is, and John, you may remember this show also, where we covered how they were able to observe black holes, right? And basically, they were using these, the way that they do this is they are using these radio astronomer telescopes, right? And they admit, first of all, point blank, that in order to be able to see that far away from where these black holes are, that it would take a radio telescope the size of the entire Earth to be able to detect it, right? And so their solution is that they took 8 observatories that were scattered all around the Earth, right? Well, and you really have to think that's kind of crazy, because if the Earth is a ball, well, right there, you're kind of really annihilating all of your detection power. But we'll just look past that, right? And so what they're doing is they take samples of, say, you have a picture, right? Right now you're looking at a 16:9 aspect that has, millions of pixels, right? And each one of those radio astronomer telescopes is picking up a pixel from a certain part of the image. And so essentially what you have something like the 5 blind men that are feeling an elephant trying to figure out what it is, right? The guy that's on his hind leg thinks that he's feeling a tree. The guy that's on his trunk thinks he's feeling a snake. The guy that's on his ears is thinking he's feeling, whatever, right? But it's that kind of concept. And so what they're doing then is they take these 8 pixels of data and then they run them through a database of what they think a black hole may look like. Not what they know anything at all about, but just what they think that it might look like. And then they run database analysis to see which one actually comes up with the best match out of 8 pixels out of billions, right, to this database. And then when they come up with their 8 pixel image and then they extrapolate the rest of it, they say, bada bing, there it is. This is what a black hole looks like. And of course, if you guys saw that black hole, it looked like somebody that was, smoking a cigarette, and the cherry was kind of lighting up, and it had the black ring on the outside of it, if you remember that, right? So,
I remember.
Wow.
So, I mean,
Wow.
It is so unbelievable, the horse manure that they put out and declare as absolute fact. And the way that they derive this is simply unbelievable. And it's going to get a lot more unbelievable, guys. We got a lot more
modeling.
to go. Yeah.
It's modeling.
Yeah, and when you... Oh, sorry, John.
No. I was just saying earlier, everything nowadays is based on models. This is why we're in the ridiculous situation we are currently with the scamdemic, but all based on models.
Yeah.
Which are nonsense.
Yeah, and the saddest part is this lady who's telling her all this stuff, she might not even know what's going on.
She probably doesn't.
Yeah,
she totally believes
She
it.
looks at a computer screen. She is not using any of her God-given senses to make this observation. Everything is done in a machine that she doesn't even get to realize. She sees the outside of the machine. She doesn't even see the process happening. And then it comes into a computer box and tells her there could have been, it could have been put in the program for both of these different facilities that at this time and this day you give off this thing, broop. Programmers can hide all kinds of stuff.
Yes,
in these
exactly.
things.
And I was going to say, so there's a comment in the chat. He says, so Bob, what do you think they're really doing there? Just curious, because we know that space is not what we thought it was. Thanks. Okay, well, St. Michael Archangel, I don't know what they're doing there. I mean, I understand fully, how the interferometer works, and we're going to go over that here very shortly. And you're going to find that the LIGO facility, and I'm going to point this out and make it clear as a bell, that the LIGO facility is none other than a Michelson-Morley interferometer on steroids. It is the exact same thing, and I'm going to prove it, right? And so what we know what laser interferometries, interferometers do, and the Michelson-Morley, there's two basic types of them. First of all, you have the Michelson-Morley type, which is a laser interferometer which detects linear movement, right? In other words, not going around in a circle or curving off to the left or right, just forwards and backwards, right? And this is the thing that so-called failed because they couldn't detect any linear motion around the sun. And of course, yeah, granted, even though it is technically a angular detection, right? Or an angular movement, because it's such a long time, on one length, you would literally be looking at it, as, by the samples, you would be literally looking at it as a linear sampling, right? Versus like the ring laser gyroscopes, which are firing beams in opposite directions and around in a circle, right? And so any angular movement, it's going to register to a very high degree of precision. So we know essentially what the laser interferometer can do in that thing. And as far as we know, the only thing it's really good for is detecting any speed. And since we know that the Earth is not moving, well, that's a problem. And then you have a whole nother problem too, that they of course shot themselves in the foot with, because remember, when they didn't detect any motion around the sun, the first thing they did is they came out with, Cavendish, or not Cavendish, but, oh God, I always forget this. The guy that, where it was shortening up, the contraction, lorentz contraction. God, okay, the lorentz contraction. So the first thing they said happened was, well, what was happening, and the reason it didn't detect any linear motion is because the detection device, or the arm of the laser interferometer, was shortening up by just the right amount, so that it matched the speed going around the Earth, right? And it's like, okay, if that wasn't a move of desperation, I don't know what was. So knowing that LIGO works exactly the same way, then the exact same physics would have to be at play. which would render the device essentially completely moot. But we know that they're not moot because we can take a linear Michelson-Morley type device and we can detect linear motion with it. Just like we can take a laser interferometer in the ring laser or fiber optic gyro and detect angular motion, right? So the devices work.
So Bob, in the current setup that it's in at the moment, let's just assume that it is a Sagnac device, but it's not spinning on a table like Sagnac had it doing. Would this thing pick up earthquakes, let's say, or any sort of surface movement, lateral surface movement?
It could be used for that, and maybe that's exactly why they built it on the intersection of three fault lines.
Yeah, I think that's exactly what it's for. It's a rich man's tool to give them a heads up as to when the hell to get out of Dodge. But isn't it just, so I love the way that they had to build two of them, that just sort of doubles your budget. They had to build 8 of these things, and that 8 triplets your budget or whatever it is.
Yeah, there's always that backstory, right? It's kind of like the movie Contact, right? When that first machine got destroyed, it's like, why build one when you can build 2 at twice the price?
That's exactly what I was thinking. But I can understand if they had one on one side of America, and that would again give them incredible accuracy on any sort of earth shake, volcanoes or anything basically. So that's what I reckon it's for.
Yeah, I agree. All right, let's continue on.
As energy isn't released as light, prior to the detection of gravitational waves, we were never able to observe them, and the very existence of such black hole binaries was contested. But perhaps the most...
Right? Did you hear what she just said? When she just said the gravitational waves, we were never able to observe them prior to that. So how in the hell do they even know this works? See, I mean, oh my God. Where is the benchmark? Where is the benchmark that shows us that it works?
Didn't they even say one time that they were running a test to see if they would see it? And they came out and said that they detected it, and then later on they came out and said, no, that was just a test. Blah, blah, blah.
That was what I was talking about.
Like that?
Yes, that's what I was talking about at the beginning of the show. The supervisor hit the button, set off a false alarm. They called the press, and then they had to recall their press release because it was a supervisor testing so-called his engineers, right? So he hits the button just to see if they know how to say, oh, look, the alarm's going off. Better call the press.
Yeah, so right there, they're telling you that they can manipulate the data. Right there.
Yeah.
Well, they clean it going out and they clean it coming in. And it goes ping on the machine. And But just thinking about what I was talking about a minute ago, would it be wildly stupid to say that maybe CERN is some sort of ring laser gyro?
It's possible, yes, but it's also possible that, and actually this is something I have a little bit different thought on this, and this is something that we're going to cover on another show, John. But I think CERN has another purpose, and it's a lot more nefarious than that.
Right.
Yeah.
Right.
So,
okay. I'll look forward to that one. But along those lines, if they had this LIGO and they had CERN, it would point to them being quite paranoid about what's happening on the Earth's surface, which sort of, I've got neon lights of mud flood going through my head at the moment. Just, does this give them sort of a heads up?
It could be. In fact, and that's something, like I said, these are all subjects we're going to be covering over the upcoming weeks, because there has been some astounding information that has come out regarding this. So anyway, let's get through this, and then we'll go through the laser interferometry tutorials and get everybody up to speed on this. So here we go.
Exciting use of gravitational wave detection is yet to come. In the very first moments of the universe, the electromagnetic force and the weak nuclear force, two of the fundamental forces of the universe, were indistinguishable. But when those forces separated, they're believed to have produced gravitational waves. And unlike light waves, gravitational waves interact extremely weakly with matter. So much so that...
So they are believed to have produced it. So they don't know this, they only believe it, and they're making all these statements in the affirmative about the gravitational waves. So that's the amazing thing. They can say, well, we're guessing, we're going to just spitball this, and then they're going to pile on all this other stuff, you know, based on this spitballing that is basically declaring it as factual, and then they're going to go and teach it in the universities. It's crazy. Let's continue.
Yeah, they use words like proven. When they start off with I believe and then end it with proven.
Yep.
It's like you can't do that.
Well,
that's an oxymoron.
The thing is like how could they spend so much money on this device if it wasn't correct, right? I mean, that's sort of the way that they couch it, right? It's like, oh, you have this multi-billion-dollar lie factory. How could they be wrong, right?
Yeah, exactly. Yeah, it's insane. It really is. All right, so let's continue on.
Gravitational waves could still be traveling from a time when the universe was a billionth of a billionth of a billionth of a billionth of a second old. If we can build a detector with enough sensitivity to observe these waves, they might give us some information about the very first moments of our universe, which is very...
Gee, I thought we already had that all figured out. I thought we knew everything that happened right at the very first billionth of a second of the universe.
One day she's going to listen back to this and just cringe.
How could I have been so stupid? All right, you know what? I think that's probably
when the universe was that young. Wouldn't the particles that make up the Earth and our bodies, wouldn't they have been right next to the particles that make up the distant galaxies? I mean, that's their claim, right? That it was all compressed into a little pea-sized, super dense object or whatever, you know, prior to the Big Bang. So everything was right next to each other at that point. So how could we just now be hearing something that happened back then? It doesn't make any sense to me. It's such nonsense.
Yeah, exactly. So, all right. So enough of Diana. Let's go on now and let's talk about laser interferometry detectors. Okay, what they are, how they work, all that fun stuff. But the first thing I said that I was going to do is I was going to prove to you that LIGO is precisely the same thing as the Michelson-Morley experiment. So let's take a look at these two things. So what do we have here? We have a light source, okay? And that light source is going through and it's splitting to two different mirrors, okay? So it's splitting, and then it comes back and it recombines, and then it comes over here and it hits an eyepiece to detect any difference in frequency, in fringe, right? So now if we look at LIGO, what do we have? We have the light source, it's hitting the beam splitter, it's going in two different directions, it's coming back up, the beam splitter is also acting as a beam combiner, and then it's going here and it's going to a detector, which is a little bit more modern, obviously, than what they had in Michelson-Morley, and it's exactly the same thing. These are absolutely the exact same thing, guys, and they're 100 years apart. Michelson-Morley, Michelson-Morley, LIGO, same thing. All right, so let's actually listen to Malcolm Bowden here on how this works, and we are going to kind of start off with him. So here we go.
In 1887, Michelson and Morley carried out an experiment to check this speed of the Earth through the ether. They passed light through two long arms, one in the direction of the Earth's travel and the other at right angles to it. The light travelling in the direction of the Earth's travel should have taken longer to return than that travelling at right angles to the Earth's direction of travel. To the amazement of the scientific world, no such speed as 30 kilometers per second was detected, but they did get speeds between 1 and 10 kilometers per second.
Okay, now, first of all, I need to tell you something that we discovered, and I discovered, well, we and FE Core discovered, because I really didn't discover it. I just got credited with discovering it, and, as a result, got credited with proving the rotation of the Earth on the movie Behind the Curve. But in this, you heard that Michelson-Morley was unable to detect that 30 kilometers per second velocity around the sun, right? But what they did detect is between a 1 and 10 kilometers per second movement, right? Well, what was causing that movement? Well, I'll tell you what was causing it, and we're going to elaborate on it here in a little bit, and we're also going to prove it. Okay, so what we're looking at is this configuration is set up to detect linear movement, right? Not angular movement, not going around in a circle, but in a straight line. But what we found was, through our experiments with the fiber optic gyro, or the ring laser gyro, fiber optic gyro, is that the luminiferous ether, which of course Einstein had to mathematically eliminate and claim was not there, is that it turns out that the luminiferous ether is propagating in a vortexual pattern, much like a magnetic wave does, right? So you have not only a centripetal and a centrifugal movement of a magnetic wave, but you also have, at right angles to that, or at an alternate angle to that, you have the same thing going on with the luminiferous ether as well. So it is in motion. And this is exactly what this was picking up between the 1 and the 10, is this was designed to pick up linear motion, and yet the angular motion going across these arms were triggering it, and it was kind of jumping up to 10 kilometers per second and down and up to 10 kilometers per second. That is why that happened. Okay, so let's continue on.
Ignoring these speeds,
do you think, one second, Bob.
Okay.
Do you think that maybe they built these to measure, they know something is going on, and they really want to be able to measure, keep an eye on this ether movement to see if it's changing or not?
Very possible.
That's what I was saying.
Yeah, but I mean, it can be used for several things. Obviously, we know it can be used as an extremely high precision, measuring tool. In fact, these Michelson-Morley type of laser interferometers are used in extreme instrument calibration, right? I had an engineer friend back in Denver that's what their shop did, is they calibrated all kinds of test equipment, and one of their things that they had was a Michelson-Morley type of interferometer to calibrate stuff. And I mean, it was amazing. We were in there on a weekend, I'll never forget this, and this thing was mounted on a steel frame on top of a wood block, right? This laser interferometer, and he flips it on. We're sitting there watching it shrink, right? It's like, what the hell? Why is it shrinking? And it turns out that because we went in there on the weekend, and actually it was a Friday night, and they had just turned down the heat, and it was getting cooler in there, right? What it was detecting was it was seeing the metal and the wood shrink because it was getting colder, and it actually measured it, right?
Wow.
So,
but what was this thing designed to measure? What was that designed to measure?
Oh, all kinds of precision measurements for, whatever, anything that requires an extremely high precision of measurement. But it in particular was designed to calibrate the test equipment for measuring these things. And I don't know how all that works. That's not my biz, but I do understand how it works.
You got to ask the question is why they build these huge LIGO facilities and CERN facilities and everything just to, to measure what's happening on the Earth's surface. Like you're saying, Zach, it strikes me as paranoia or insider knowledge that they are trying to detect something before anyone else knows about it.
Yeah, and that very well may be, but I mean, I just don't have enough information to speculate on that, but it could be that.
No,
because
pure speculation, yeah.
Sure. One thing we do know is that, supposedly, prophetically, according to the Bible, days are supposedly supposed to get shorter. We're already seeing things happen electromagnetically that are weird, to say the least. Whether or not it's a natural phenomenon or it is something that is being caused by a man-made technology, I don't know. But I think that they are trying to manipulate it to some level, and that's what I'll talk about when we get into CERN on one of these shows, and how that's working. But yeah, there's obviously lots of uses for interferometry, and it is in use everywhere. And the irony, like I said, is the very philosophy, the very thing that it operates on, which is the luminiferous ether, they say doesn't exist. And if it doesn't exist, then there's no way that these devices could work, and yet they work perfectly. So that's another thing that just blows your mind. All right, let's continue.
Always referred to as giving a null result. This shook the scientific world, and to overcome the implication that the Earth was stationary, they invented the Fitzgerald-Lorentz contraction. This claimed that the arm that was in the direction of the Earth's travel became shorter, so that the time to return was the same as in the other arm.
Right. So they're saying then, because of this Fitzgerald-Lorentz contraction, that's the reason why it didn't detect the motion of the Earth around the sun, which is complete nonsense, because even 100 years ago, they were just completely spitballing. And this is obviously not the first time they've come up with this ridiculous excuse, because the Fitzgerald-Lorentz contraction was adopted by Einstein in his theory of relativity, and it's used throughout virtually every facet of it, to basically muddy the waters or muddy the data set. It's absolutely unreal.
If they're talking about the Lorentz contraction being as small as, what was it, an electron or a proton or whatever, over 4 kilometers or whatever, to say that it's interfering with something the size of Michelson-Morley's experiment, I mean, that's as ridiculous as saying that Michelson-Morley incorporated or made allowance for the curvature of the Earth on the top of their tabletop, you know?
Exactly. It is crazy, but like I said, there are lots of uses for it. So let's get into this and explore it a little more. Here we go.
There was absolutely no justification for such a solution. It was only invented to overcome the idea that the Earth was stationary in the ether. As Arthur Miller stated, this invention of the Fitzgerald-Lorentz contraction was a physics of desperation. So troubling was this to scientists that eventually Einstein produced his relativity theory, by which he overcame the problem by simply abolishing the ether. He first said that he did not know of the Michelson-Morley experiment, but later admitted that he produced his theory to overcome the Michelson-Morley result. But abolishing the ether caused many problems with Einstein's relativity theory, which I have exposed in a separate video dealing with this fraudulent theory that is maintained by propaganda. Einstein's biographer commented, "The problem that now faced science after the Michelson-Morley null result was considerable, for there seemed to be only 3 alternatives. The first was that the Earth was standing still, which meant scuttling the whole Copernican theory and was unthinkable. The second was that the ether was carried along by the Earth in its passage through space, a possibility which had already been ruled out to the satisfaction of the scientific community by a number of experiments, notably those of the English astronomer James Bradley. The third solution was that the ether simply did not exist, which to many 19th century scientists was equivalent to scrapping current views of light, electricity, and magnetism and starting again." Notice that the last 2 possibilities are quite different from the first one. The first possibility is rejected not because there was any scientific result that contradicted it. Indeed, it is the only one that fits all the results of the experiments carried out. The other 2 run into huge experimental problems, requiring much mathematical juggling and sleight-of-hand tricks to come to their defense.
Okay, so, and I want you guys to know that Michelson-Morley has been repeated. And here's the interesting thing about it. It was repeated about 2 decades ago, something like that, in the 90s. By
86, I think it was.
Was it 86? Okay. By none other than the United States Air Force. And guess what, guys? They found that the ether did exist. But mainstream science being what it is, and they have to go by Einstein's dogma, even though they will readily admit that there is something there, they dare not call it the ether. right? And it's going to be cool because I'm going to play a clip for you of a physics professor that is saying point blank that, you know, science invented and is teaching in academia the idea of particle theory. And the only problem with particle theory is that it's a blatant lie, right? And then he goes on to describe, without saying the word ether, he goes on to describe the word ether perfectly as to what is actually going on out there. So again, it's so funny to watch these guys avoid at all costs saying the word ether, right? They just can't say it. So let's continue.
The first is rejected because of the purely philosophical horror of having to accept the possibility that the Earth truly is stationary and at the center of the rotating ether. The Earth really is at the center of the universe. It is the geocentric model that actually has by far the best support from the scientific results we have been examining and the simplest explanation of them. The Michelson-Morley experiment is the only one of 4 experiments that is well known. The other 3 experiments never taught are: 1. The Michelson-Gale experiment that showed that the ether was passing across the surface of the Earth once every 24 hours. 2.
Okay, now I want to say something. You know, I've been credited with establishing the rotation of the Earth when in fact that last experiment that you just saw, the Michelson-Gale experiment, was actually done, 100 years ago, and it in fact detected the ether moving over the Earth's surface at 15 degrees per hour, right? And then when they came up with that, they had to then differentiate whether it was the sky that was causing that, or something, energy coming from the sky, the luminiferous ether, or if the Earth was turning. Well, we've got Airy's failure, which was the optical experiment in telescopes that told us that it is in fact the sky that is moving and the Earth is stationary. And we also, have a few other experiments that were done. So these weren't just done, 100 plus years ago. These experiments have been repeated several times. I'm only going back to some of the original experiments that people refer to. But yeah, it's most recently been done by the United States Air Force and confirmed the ether absolutely does exist. And, even the last 3 Nobel laureates have said straight up, the ether does exist. All right. Yeah. You want to argue with them? Go for it.
Airy's failure was called Airy's failure because it failed to show that the Earth moved. But people are so blinkered or zombied that they just see the word failure and they rule it out. If you take the time to understand Airy's failure, it's such a beautiful experiment, and it proves unequivocally that what is above us is moving and the Earth is stationary. It's that was a massive eye opener to me.
You don't need a 2-mile long building to do it either.
No,
it's actually something that can be duplicated by anyone.
However,
back garden.
The longer the arms, the more resolution you will have. So I will give you that, and that makes sense theoretically as well. But you're right, you don't need it because aircraft are running around using these ring laser gyros, and that device is no bigger around than a water cup, right? It's very small. So,
and of course, but we have to reject Airy's data and call it a failure because the Earth must be a spinning ball no matter what.
That's right. That's
exactly.
Right. Heaven forbid you go with the scientific results, but they have to do everything in their power to nullify them, even at the cost of inventing ridiculous things like the lorentz contraction. Nonsense.
But once again, we are the science deniers.
Yes. We're the science deniers. Let's continue.
Every 24 hours. 2. Airy's failure experiment proved that it was the moving starlight carried by the rotating ether that was passing across the stationary Earth. 3. The Sagnac experiment that proved there was an ether, thus demolishing relativity theory.
Yes, so ballers out there, the ones that want to say, thanks, Bob, for proving the rotation of the Earth. Did you hear what he said? He said the starlight that was carried by the moving ether, which is precisely what the fiber optic gyro detected. I reported it honestly. I was not trying to hide anything. We were blown away when we saw that. And then when we did a little bit of research into it, we figured out what it was. We figured out exactly what was happening. And then, guys, beyond, not only did we figure out what was actually happening, we figured out a way to prove it. And the way that we proved it was to take that very same fiber optic gyro, and we knew that if it was behaving in a vortexual pattern, then it would be rotating at different rotational speeds at different elevations, right? Different parts of the z-axis would be rotating at different speeds. So what did we do? We took that fiber optic gyro, we went to Pikes Peak, Colorado, which has a 14,125 foot elevation. We took our measurements there. Then we went directly east of Pikes Peak on the precise same latitude line, right? Because if you're on the same latitude line, then your rotational rate must remain the same. So we went due east and we dropped about 10,000 foot out on the plains of Colorado on the exact same latitude line, and we got a variance of about between 1 and 2 degrees per hour. So 1 and 2 degrees per hour is, 30 or 40 degrees per day difference. Now, on a ball, that can't happen.
Huge.
That can't happen, guys, because the ball is stuck at 15 degrees per hour, period, right?
Yeah.
But when we were able to actually measure it and go up and down on that z-axis and see the different rotational rates of the ether, that completely annihilated the idea that it was the Earth spinning, because it does not vary by 20 to 30 degrees per day on its rotation. Sorry, guys, doesn't work that way. So
thanks, Sagnac.
Yeah, thanks Sagnac. And thanks, Bob. And thanks, Zach. Zach was there too, man. Zach was right there during those experiments.
Yeah, I think those need to be done. I can't wait for this to explode so we can start doing these on every longitude, every latitude at the same time even.
Yeah. The ballers will never do it.
Nailing it down. No
ballers
way.
will never do it. They will be content to say that I proved it. Yep.
Oh, yeah.
But yeah, I dare them to do it, because you know what? The results are going to be exactly what we got, and then they are going to have to admit that what we discovered is the absolute truth. And that is why you will never see them do these experiments. They will only sit there and try and shoot holes in it by saying, oh no, sir, the ether doesn't exist. But you never see them go out and get a fiber optic gyro and do the experiment and measurements themselves. That will never happen, because these ballers are just a bunch of losers, you know? They have no idea.
Wait. You wait, Bob. Next week, Wolfie 6020 will have just a brand new interferometer that he's just found in a drawer with property of NASA stuck on the side of it. And we'll look forward to that one.
Yeah, absolutely. All right, let's continue.
Made separate videos giving more detailed explanations of the last two. Let us examine briefly these three experiments. The Michelson-Morley experiment used sealed tubes covering a large area that measured the speed of the ether relative to the surface of the Earth. They obtained a value that was within 2% of the known speed of about 0.45 kilometers per second at the equator.
AKA 15 degrees per hour, ballers.
But this speed could have been due either to the Earth spinning in a stationary ether or the passing of the rotating ether around a stationary Earth. It was Airy's failure experiment that proved it was the moving ether passing across a stationary Earth. If the Earth was stationary and the stars were stationary, the starlight would come straight into the telescope. However, if the telescope is moving at, say, 5 miles an hour, you would then have to tip the telescope, let us say, 5 degrees to see the star. However, if the starlight is being carried across the surface of a stationary telescope at 5 miles an hour, you would still have to tip the telescope at 5 degrees to see it. So you cannot tell which one is stationary. To see whether it is the telescope or the stars that are moving, all you have to do is to fill the telescope with water, which greatly slows down the light when it is in the telescope. If it is the telescope that is moving, then you have to tip the telescope a little further because of the slower speed of the light in the telescope. However, if it is the stars that are moving past the stationary telescope, then the telescope does not have to be tipped any further because the starlight is coming in at the correct angle anyway. that Airy failed to find any further tipping was needed proved that it was the telescope, and therefore the Earth, that was stationary. This important conclusion was not even mentioned in his report. It was too explosive.
All right. So,
genius.
Yeah, absolute genius. And this is something, by the way, that F.E. Corey is going to replicate once we, get our act back together, and hopefully some of this COVID stuff slows down and we can actually get back to doing the science that we want to do. But that is something that is on the slate to be done, is we're going to redo the Aries failure experiment and show the whole world that it is, in fact, the lights in the sky that are moving and not the Earth. And we already have proof of this from multiple experiments, and we have zero proof, guys, zero, that there is any movement coming from the Earth in any of the 8 or 9 different directions at the different speeds going up to 1.3 million miles per hour. There is no motion detected. The Earth is not moving. Plain and simple. Every scientific test that has ever been done proves that conclusively. And it is amazing the way that this desperation of keeping us in this, spinning ball illusion is being propagated.
Also,
what's so amazing?
Well, I was just going to say, also, as any 5-year-old child could tell you if you asked them straight out without any programming.
Yeah.
Mm-hmm. That's exactly what I was going to say. I mean, it's obvious to anybody that the Earth is stationary. And so it's only because of these wild theories do we need these multi-billion-dollar machines and just cockamamie theoretical experiments to tell us, wow, so it is stationary, so our senses are true. But yeah, isn't that funny, though, that a child could tell you that?
Yeah,
it really is.
I assume LIGO was built with taxpayer money, was it?
Oh, absolutely.
Right.
Yep.
So they're hardly going to say, we're building an ultra-sensitive vibration detector so that we can tell all our mates to get into their bunkers, 5 days before we say anything to you guys. But what we will do is sell them on absolute horseshit that what we're doing is measuring gravitational waves 1.3 billion miles away, or trillion or quadrillion, doesn't really matter, does it? But
it's ridiculous.
Yeah, I can see the whole agenda here now. Yeah.
Yep. So, all right. So now we're going to move forward in laser interferometry detection to angular detection. Now that is where, the Michelson-Gale left off, and the Sagnac greatly elaborated on. Again, not only proving unequivocally that the ether does exist, but that this is, that it can be used to detect to an incredibly high level of accuracy motion, left, right, up, down, whatever, on any axis whatsoever. That's what it's used for. So I'm going to let Malcolm explain this, and then we will elaborate from there. Let's go. Whoopsie.
In 1913, Sagnac carried out a simple experiment of passing light in opposite directions around a table and recombining them. This produced interference fringes. He then rotated the whole table at 2 revolutions per second and found that the fringes changed. This result has very significant implications in science. It works as follows. A beam of light leaves the light source at the bottom left-hand corner and is split into 2 different beams, which we have coloured red and blue just to distinguish them. They travel round the circuit in opposite directions until they eventually reach the splitter, which also recombines them. There, they then go on to the photographic plate, where they have interference fringes. In this simplified version, we see that the beam is split into 2, the red and the blue again, and they go round the circuit and are recombined at the splitter and recombining prism, so that they again produce the fringes on the photographic plate. Now let us rotate the table. Before we do so, there is the very important subject of the effect of the ether. The Michelson-Morley experiment failed to detect the 30 kilometers per second motion of the Earth through the ether. So as to overcome this problem, Einstein simply abolished the ether in his relativity theory. The very significant result of the Sagnac experiment was that it proved that the ether existed. Let us see how it did this. It is a fundamental feature of relativity that it claims that as there is no ether, light travels away from a source at the same speed relative to the source, whether the source is moving or not. Thus, whether the table is turning or not, the fringe patterns should stay the same. But if the ether exists, once the light has left the source, the speed of the light is controlled by the ether, independent of the speed of the table, mirrors, etc., as we see here. So let us see what happens when we rotate the table. Here, the light is split, and the red and blue lights go in opposite directions. But notice that the left-hand mirror has moved around in such a direction that the distance the red light has to travel is further. Now in relativity, the same time should be taken because the splitter is also moving and the distance between them is the same. But now imagine that the ether exists and the speed of the light is controlled by the stationary ether. Imagine the ether like a thick treacle that limits how fast the light can travel, independent of the motion of the light source, the splitter, or the mirrors. The result is that the red light takes longer to reach the left-hand mirror. Similarly, the right-hand mirror is coming towards the blue light, so it reaches the mirror quicker. After they change ends, the red light again takes longer to reach the recombiner, whilst the blue light gets there quicker again. So they reach the photographic plate with a delay between them, and this changes the fringe pattern. In fact, Sagnac, using the speed of the rotation of the table, calculated how much the fringes should change, and found that they did change by just that amount. The crucial feature of this experiment is that it demonstrates that the ether does exist, which demolishes relativity. How does the scientific establishment deal with this result? By muddying the waters with scientific gobbledygook. Wikipedia says, in the above discussion, the rotation mentioned is a rotation with respect to an inertial reference frame. Since this experiment does not involve a relativistic velocity, the same wording is valid both in the context of classical electrodynamics and special relativity.
All right. Now, first of all, guys, this is how mainstream science, this is their excuse for everything, right? They put everything into a so-called inertial reference frame. In other words, they cut it off from absolute values, right? So when you ask, well, how could Apollo, right, blast off and fly to the moon? And if the Earth is traveling at 67,000 miles an hour around the sun, and the sun is traveling at 500,000 miles an hour around the Milky Way, and the Milky Way is traveling at 1.3 million miles an hour around the Great Attractor, how is it that the Apollo spacecraft didn't just get left in the dust, right? Especially when it's going through Lagrange points, right? Things where there is no gravitational attraction because it's essentially nullified, right? So it wouldn't have anything to carry it along in that current. So their way of dealing with this, guys, is to put it in what's called a inertial reference frame. And all they're doing when they do this is mathematically cutting it off from the rest of the construct and focusing on that one little piece and acting like nothing else is going on around it. Much like when we see how they depict the solar system going around and planets going around the sun, right? And the sun isn't moving at all because they've cut all that motion off, because all you're looking at is a quote unquote inertial reference frame that omits the rest of the motions out of the equation. Now, in real life, this does not and cannot happen. So again, the fact that anybody can get a PhD and not see this clear as day boggles the mind. It really does. It is hard to believe.
They just say, let's ignore the immutable laws of physics in order to suit our theory and make our theory look better. And they're fine with that, right? I mean, I don't understand the mindset, but and then they call it science to boot. I mean, that's what really gets me.
Yeah.
Just look at the pretty lady and stop thinking enough.
Yeah, it's completely, it's insanity. It's absolute insanity. You know, it's like it seems like when these people get their PhDs, they leave their brain at the door. Seriously. It's just incredible.
That is part of it. They turn into...
Well, yeah, that's how it is, because you are not allowed to think for yourself and go against the status quo, or else you don't get paid with that little piece of paper you got.
Become a parrot.
Yeah, that's right. And that's right. Anybody that goes against what the mainstream science and the Rockefeller school system is teaching, of course, gets their degree pulled, or they get laughed out of the scientific community. They don't get any funding. They don't get any employment. And of course, they're dealing with, a 6-figure tuition debt, right? And this has happened to even some of the most brilliant scientists in the world. They come up with something that...
It's the same with doctors these days.
Exactly.
All they have to do is grab I can't remember what it's called, the DMG or something. My dad was a doctor, and look up the symptoms, and it just says, right, prescribe this concoction to them. And basically that is... Yeah, it's just mental. We've lost all of our sort of fundamental... skills.
Yeah, absolutely.
Doctor by numbers, right? Like color by numbers, but it's for doctoring.
Yeah, or driving by braille, whatever.
Yeah.
All right, let's continue.
How on earth can it be valid in both theories? It clearly proves that the ether exists because the speed of the light is controlled by the ether, independent of the rotating table and mirrors.
Right. So the way it can be valid in both theories is to simply cut off the rest of the equation from it. Again, put it in its own inertial reference frame, that's like saying that, what's a good example? If I was on a merry-go-round and I was playing catch with somebody on the merry-go-round, and then the merry-go-round started up and going around in circles, right? Well, we know, by the Coriolis illusion, right, that if I throw a ball in a merry-go-round, it's going around in circles, that ball is going to appear to go off on another direction when that actually isn't happening. But see, the problem is if you look at it under its own reference frame between me and the guy I'm playing catch with, well, then everything's going to be fine. We're going to be able to just throw that ball back and forth. But as soon as you put in the real world, which is that we're sitting on a freaking merry-go-round and all of us are included in the reference frame, then that ball is going to go all kind of different directions, right? And the physics and the mathematics behind it are right out the window, right? That's how it can be valid.
That's a good analogy, yeah.
Yep, let's continue.
This Sagnac effect is used by airlines for their compass directions. As the plane turns, the change in the fringes are translated into a change in the direction of the plane that then registers on the cockpit compass. In addition, I have received comments from 2 scientists complaining that they were never taught about the Sagnac experiment. The first said, "After 35 years as a professional physicist with a thesis in relativity, I only learned of Sagnac's experiment last year." Another correspondent complained that his professors never mentioned these important experiments. Dear Mr. Bowden, thank you for your enjoyable and well-written website. I've enjoyed visiting there today. I was especially interested in your comments on geocentricity, which, as noted, are controversial. The amazing thing is that none of the experiments cited were ever discussed in my undergraduate education, nor the implications cited. All my life I have heard the story of how Copernicus's theory came to prevail. I would have thought that major experimental evidence, already in existence, and calling the theory into question, would have at least been cited. One feels cheated as a student, of course, to keep finding 25 years later these bodies of contrarian evidence that never are mentioned in the classroom, unless a student has already researched the topics and brings them up.
Right. And when that student does bring it up, what do? Then they bring in the concept of the inertial reference frame and just, depending on the student, he's either going to be smart enough to see through that or not, or he's going to be labeled as a dissident or a troublemaker, and he's not going to get his degree, and there goes all that tuition. You get the pattern here. This is the way that it works, guys, and it's just unbelievable. All right.
Well, now they have the University of Globebusters to attend. They have no excuse, do they?
Yeah.
Well, and it shows why over the last 150 years, most of our great advancements in technology happened from fringe scientists that weren't going along with the status quo.
Yeah, exactly.
Well, it's like the inertial reference frame allows them to make the claim that while the Earth is a spinning ball, going in 5 different directions at once and all kinds of wild velocities along curves, it's just like it's stationary, right? Because the inertial reference frame, that's one of those magic words they can just throw in there and abracadabra. It's like it's stationary, but it's not. Of course, it's not stationary, but it's just as if it were.
Yeah, exactly.
Just, right.
And that's the irony, John, is that with all the technology that we have in not only interferometry, but in accelerometers and all other plethora of navigational test equipment, measuring equipment, none of it can measure any motion of the Earth, not spinning, not moving through the universe, nothing, right? Einstein even said, I've come to the idea that no optical experiment can prove the motion around the Earth. Well, you know what, guys? If these ballers really believed in Einstein's nonsense, they would never be saying, thanks, Bob, for proving that 15 degrees per hour, right? Because Einstein says you can't do it. But, well, the ballers, the trolls know better, right? They know better than their idol Einstein. But,
but
I will say this.
Einstein said that after Airy's failure experiment.
Exactly.
So he's a lying POS.
Yes, he is. And Einstein, we could delve into his background, but this guy was a piece of work, to say the least. But I'm not going to go there with that because I want to keep it scientific. But as a human being, he was a real POS. I can tell you that much.
Well, anyone out there should search the 2 words Einstein and shitbag. Sorry.
Yeah, exactly. All right. So now what I want to go to is I found this little gem. And when I was doing some research, now I've covered this video maker before. And if you guys are not subscribed to this guy, what is wrong with you? But this channel is called Don't Sphere the Truth. All right. Now, this guy is without a doubt one of my favorite video makers because the way his mind works, he doesn't do a lot of narrative or anything like that, but he lets the videos and the results of other videos speak for him, and he will put that information out there right in front of your face, and you can pretty much put the pieces together. And the way that he does his research is absolutely top-notch. So if you guys are looking for other channels that are exceptional, nothing short of exceptional, Don't Sphere the Truth is one you definitely want to subscribe to. Okay, so this particular video, I was reviewing it because we talked about the so-called ionosphere and how the ionosphere supposedly does all these crazy things like bounces radio signals down and bounces them then off the Earth and then back off the ionosphere so that we get these communications that can go all around the world, right? They had to introduce this concept of the ionosphere to keep the myth of the curvature or the globe alive, right? So one thing that's really beautiful about this particular work, I'm going to show you this one piece that's in here, but this video shows that it's not the ionosphere that's doing any of this. It's actually the firmament, and how the firmament, and there are certain characteristics in crystalline formatures, crystalline growths, I should say, especially when you have an electric current that's put across them that changes the characteristics of those crystalline forms to be able to do things like maybe bounce satellites back, satellite signals, microwave signals back. There is a very definite geometry that it can be formed at. It's absolutely amazing. But all of that is beside the point. The thing that I found in this that was an absolute gem is he comes across a physicist that is running a lecture, and he is talking about how the academia is trying to make all of the, trying to teach everybody that, it's all about particulates, particles, electrons, protons, neutrons, et cetera, et cetera, et cetera, right? Itty bitty teeny tiny particles, right? Instead of the ether and things manifesting from the ether. But what he's going to tell you is, he says the problem with that is it's a lie. He goes, well, it's kind of a white lie. No, it's not a white lie. It's a big lie. And the reason for that is because they are admitting straight up that what they're doing is they're teaching graduate level students that everything is manifesting out of smaller and smaller particulates or particles. And they know full well that it's a lie, but it makes it simple to teach. And then he goes on to describe exactly what it is that's doing this. And without saying the word ether, this man is going to describe the ether to a T, right? So I'm just going to play a little bit of this video until you get the point and see what you think about this. This is crazy. Here we go.
Fact contradicts the ionization theory. See for reference the discovery of the orgon, volume 2, the Cancelopathy.
Okay. I backed it up a little bit too far.
Because that's what the ionosphere is. It's all charged particles.
There are like Lego bricks from which everything in the world is constructed. These Lego bricks are particles, and the particles are the electron and two quarks. It's a very nice picture. It's a very comforting picture. It's the picture we teach kids at school. It's the picture we even teach our students in undergraduate university. And there's a problem with it. The problem is, it's a lie. It's a lie.
This is Houston. Say again, please.
The problem is, it's a lie. It's a lie. It's a white lie. It's a white lie that we tell our children because, we don't want to expose them to the difficult and horrible truth too early on. It makes it easier to learn if you believe that these particles are the fundamental building blocks of the universe.
Because that's what the ionosphere is. It's all charged particles.
But it's simply not true.
It's simply not true. Now, he's got to tell you here that we again, he said it's a lie, it's a white lie. Why they describe these as particles. Now, this chap is telling us that in amongst everyone else that are talking about these protons and neutrons and what have you, that we can construe, quite rightly, that they're particles. And he's saying they're actually not. But we tell you that so you can grasp the fact that there's something there. He's going to explain now exactly what it is.
The best theories that we have of physics
do
not have underlying them the quark particle and the two quark particle, and the electron particle and the two quark particles.
They don't.
In fact, the very best theories we have of physics don't rely on particles at all. The best theories we have tell.
And by the way, that theory that doesn't require on particles at all is etheric physics, where form is manifest vibrationally, cymatically, through the ether. Remember, if you're going to vibrate something or cause waves to go through something, and if you were watching the show on Sunday, we gave a very vivid demonstration of that. Things come to form. And not only do they come to form, but they come to form in very specific frequencies and very specific octaves of frequencies, right? This is stuff, guys, again, that we can demonstrate every day of the week. In the lab, at home, in your school, anywhere. This is something that is doable by every single one of us. And because we don't ever want to accept the simplest, most obvious explanation, we always want to believe that somebody else is smarter than we are, we're always going to try and defer that off to these guys that have doctorates that, quite frankly, guys, are morons. Okay? Simple as that. And they even tell you to your face. This is not the first guy to say this. John, I'm sure will remember. I did a show a couple years ago of several university professors that straight up admitted that they, half the stuff they teach people, they don't have any proof of it whatsoever. These are just, axiomatic as far as they're concerned, but there's no proof whatsoever for it. So what he's going to describe here, without ever saying the word ether, is precisely just that. So here we go.
Tell us that the fundamental building blocks of nature are not particles, but something much more nebulous and abstract.
The
The
ether.
fundamental building blocks of nature are fluid-like substances
The ether.
which are spread throughout the entire universe and ripple in strange and interesting ways. Okay? That's the fundamental reality in which we live. These fluid-like substances we have a name for. We call
ether.
them fields.
And there you go. He's going to show a picture of a field there now, people. So there you have it. So he said they're very nebulous and they're abstract, or fluid-like, in a state of change or continual change, at an atomic level. So they're energy substances that are, these waves and the fields, and that's what we're all made up of, not discrete particles as such. So I had to take my hat off to you, David, and say thank you very much for being open and honest. And I won't play on anymore. I just wanted to get this out there.
It's a lie.
During the day, enjoy the sea of particles, freshly energized by the sun.
Okay, and as far as the rest of this video, like I said, it is focused around the ionosphere, which is this notion that there is a sea of charged particles above us that are bouncing around electromagnetic waves. And of course, even that is nonsense when you think about how they're supposedly putting signals through it, right? When you have something that on the one hand, they're saying acts exactly like a Faraday cage and blocks all EM signals or reflects them back. But on the other hand, when they need them to work, well, they let those signals go all the way 2 billion miles away to Voyager, right? Unbelievable.
And this is never, the ionosphere is completely theoretical.
Yes.
Maxwell changed Ampere's equation with no scientific backing to changing that equation. So Maxwell's equations, actually, number 4 and number 1 contradict each other. One says you have to have some type of matter to have an electric field, where the other one says you don't need matter, that we can get energy from the sun, this positive energy from the sun, through a vacuum, and then gather it on our sphere Earth.
Yes, which
That's
is an
never been
absolute
done.
lie. That's right. You cannot have an electrostatic energy unless you have something to transfer that static energy to. It requires a particulate of some kind, right? So if you are trying to generate electrostatic energy in a vacuum, what are you going to charge? What's in the vacuum to charge? Nothing. Therefore, electrostatic energy will not work in a vacuum. What will work in a vacuum? Well, electromagnetic energy will, because again, what you are perturbating there is the luminiferous ether and not charged particles. There's a very distinct difference between the two, even though that they are very, very much related. So,
yeah. Something that struck me as quite interesting was I think wherever that guy was lecturing, I think that's the same set or the same lecture theatre that the Royal Institute Christmas lectures was set in, which was including Eric Laithwaite and his gyroscope experiments and everything, and I wonder if the RI in the top left corner stands for Royal Institute. Something just strikes me as though they've got to tell us this sort of stuff, and that is a statement that guy made, is something that's not commonly known. Sure.
Yeah, exactly. Well, there are several people out there that know the reality that's going on, and they are also smart enough to keep their mouth shut about it.
Well,
otherwise,
yeah, sure, but
they'll be out of
what
a job.
they teach you at university is not that, is
exactly. Exactly, and that is a problem. That is definitely a problem, and it is coming out more and more, especially with the advent of social media. But these are these are the kind of guys that there will be consequence to that guy that made that statement. Maybe because of us broadcasting on the show, it's going to come back on him in a very hard way. Even though it is absolutely 100% the truth, if it doesn't follow the company line, well, We all know
Well,
what's going on with that, right?
That's what I'm saying, is that I think that is the Royal Institute set, lecture theatre. So if it is, then this is the information they want you to hear, but they know that so few people are going to hear it, other than their own little cliques, if you know what I mean. So it's the same with Lathwaite and the gyroscopes and stuff. They would do their Christmas lectures, knowing that, you know, it would just go over the head of most people, and most other people wouldn't even watch it, but they told you.
Yeah, I completely agree. So, yeah, it's pretty crazy. So, the next thing, let me see if I can bring something up real quick here. Laser gyro. I'll just kind of go through this really quick. Audio article. Look, there's me.
Cheers,
Laser gyro, the best proof of flat Earth. Yeah, look at it. I'm all over the place in there because these idiots think that I proved rotation of the Earth. I mean, this is seriously, guys. All I did was put in Honeywell ring laser gyro, and I'm everywhere in there, man. Complete morons. That's all I can say. Complete morons. Gotta love it.
Wear it with pride, Bob.
I do, because, you know, I know better. I know exactly what happened in that movie. And, you know, the fact that these idiot ballers are going around touting that, you know, like I proved it. And they can, that's what they have to do. Why? Because there is no mainstream source that they can point to. Well, there could be. They could have pointed to Michelson-Gale, but unfortunately, that was nipped in the bud right at the very beginning, 100 years ago. So now, all they have now is a flat earther 100 years later that says, wow, we detected a 15 degree per hour rotation in the ether. But of course,
University of Globebusters, mate. University of Globebusters.
Yeah, and regardless of the fact that I said point blank that it was the ether or heavenly energies, they completely ignore that, right? They have to put it in their own reference frame and say, oh, well, that he had to mean the Earth. He had to mean the Earth. And so Bob Nodell, flat earther, which got the Nodell Prize for it, proved the rotation of the Earth. And that is who they cling to. I am their hero. And it just goes to show you what utter morons they are.
Was it ironically 100 years after the Sagnac experiment or Michelson-Morley experiment?
Pretty much, right in that same. Yeah,
not far
crazy.
off, is it?
Yeah,
well done, mate.
But anyway, yeah, I was gonna go ahead and just, you know, play the ring laser gyro and how it worked. But it's exactly the same thing. Malcolm Bowden, you know, put it out there. That is exactly what these pieces of equipment were designed to do. And they do. It was a surprise to us initially because I was aware of the Michelson-Morley experiment, but I really was not aware at that time the properties of how the ether behaved, right? So obviously I went on a really big learning curve in a big hurry. And the thing is that it was no more than a week after the filming of those and many months before that movie was ever released that we figured it out. We put it out on Globebusters, and then I sent that information to the makers of Behind the Curve, and they chose to completely ignore it and not put it in there. And in fact, at the time that they released the movie and, you know, for the initial premiere, I was invited to that premiere in Denver, and the last scene where Jeran was saying interesting, or they made it look like he had actually proven curvature, and the scene where I was at the meetup, you know, talking about, wow, it just doesn't look good, you know, because we're detecting a 15 degree per hour rotation. That was not in there, right? So it was only at the time that Netflix bought it, as far as we can tell, that they decided to, you know, get all the cutting room floor footage and put that back in there, because obviously their agenda had to be that they had to come up with some sort of proof anywhere. And this was the perfect opportunity for them to say, look at these stupid flat earthers. They have the results staring them right in the face and they still ignore it, you know, and they have no other proof whatsoever. So it's just amazing.
Cheap. is what I'd say. Very cheap.
Very cheap shot, yes. So, so there is another movie coming out very soon, and God, I always forget it. It's Shelley Lewis's movie, where we actually got to tell our side of the story on that and what actually went on. But it's very much like what we described here for you today. This is not, guys. This is not rocket science, and honestly, rocket science is not complicated. The clowns at NASA only want you to think that it's complicated. Because they want you to believe things about it that are impossible, i.e. rockets don't work in space. That's easily provable. It's a violation of Newton's third law of motion, and it just simply doesn't work. But again, this whole concatenation of mythology about space is just built on one lie after another, and all of these lies are built on things that most common people cannot test for themselves. Well, fortunately, here in the 21st century, we can test a lot of this stuff for ourselves, and that's why the box is falling apart, if you will, right?
It's a what is it? A card castle.
Yes.
Jesus, can't even think. It's getting late here. Sorry.
Yeah, that's okay. We're about ready to wrap up here. Yeah, it really is a house of cards. And of course, when Flat Earth was taking too big of a hold, what did they have to do? Then they went before Congress. Congress said, all right, YouTube, what are you going to do about these flat earthers? Well, we're going to promote more authoritative content. Authoritative, yes. Bullshit, absolutely. That's exactly what their authoritative content is myths and lies and BS and things that are absolutely pseudoscience and unprovable. So obviously, Flat Earth was one of the biggest threats to them because Flat Earth is the biggest illusion. There are other ones that are equally as big, and we're going through that right now. I can't mention what that is, but you guys know what it is already. I don't have to mention it. That's something that we can talk about on the Sunday shows. And speaking of that, guys, you're listening to the Wednesday night edition, which, of course, on Rockfin and on DLive and on YouTube is a free show. But we have also our Sunday, the main show is on Sundays, and it will be exclusively on Rockfin on the premium services, and we would love for you guys to join us if you can. The great thing about Rockfin is it is a platform, and because it is a subscription-based platform, we can actually exercise our free speech on it because it's not corrupting anything public. They cannot basically go after them because people are paying to hear this. Therefore, they can't say, well, you're corrupting the public database or anything like that. And in addition, Rockfin treats its creators very well. It actually allows us to make some money back for all the time and effort and everything that we put into it. And it's a good thing. It's a win-win situation for everybody. So, for $9.99 a month, we are bringing over so many flat earthers. We've got ODD TV. I just sponsored UAP in today. Zack will be joining it at some point, I would imagine. Jeranism, of course, is on there. Rose 777, Crow 777. It just goes on and on and on. We're bringing over a whole fleet. And the beautiful thing about this is if you sign up with Rockfin, you get access to all of that premium content for $9.99 a month. And it helps us. It helps, and it definitely lets us say what we need to say point blank without the fear of being shut down by YouTube, for some sort of channel violation or community guideline strike or anything like that. So I just want to ask everybody to consider doing that. And of course, if you can't, we understand that 100%. And that's why I have opted to do the Wednesday night show and keep it free, because there are some things that still need to be put out there for everybody. And, stuff we covered tonight, granted, we have covered it before, but a flat earth is growing at such an incredibly expansive rate. I mean, God, tons of people, even with all the clampdowns that, YouTube and the mainstream media is doing, it's still growing at a scary fast rate, and they're worried about it. And so, they will just continue to elevate the catastrophes until our attention is sufficiently diverted somewhere else where it's not on them and their lies. So that's how it's all done, guys.
Yeah, well, they should
Yeah,
be
I
worried
think
about it.
sending everybody home and giving them all that time, that was just dumb. That was a mistake. I mean, I know they had to push their little agenda, what they're doing, but I mean, that just gave people time to sit around and look at anything, you know, stuff they didn't have time to do before.
And let's face it, it's only a matter of time before each and every one of them, or you guys, are kicked off GooTube. So you need to find somewhere else to be. And yeah, Rockfin seems as good a place as any.
Yep. Yeah. And like I said, their philosophy is, you know, reward the creator. There are no ads on Rockfin at all. So you don't have to be worried about commercials or anything like that. It's just pure content. And the creators are rewarded with the majority of the subscription fee that goes into that. And it's about time is all I can say. It's a really, really wonderful thing. Of course, it's not easy necessarily to become a creator on Rockfin because you already have to have, you know, a fairly decent following and stuff like that. But once you're in, then it's really good. So to say that the creators that are on Rockfin are absolutely the cream of the crop, that they are, because everybody has to go through the screening process, and we were lucky enough to make it through it. And I'm honored to be on it. And, you know, the rest of the people that are on there are absolutely top notch. So it's a cool thing. So, all right, guys, I think we're going to call that a show and wrap it up. We're going to be covering, I think, on next Wednesday, the Great Baldini will be back with us, and we are going to expand, I think, probably on the ionosphere and, you know, more electrical things, because you know us, we're kind of science nerds, and we like to, you know, contrary to popular belief, flat earthers very much do believe in science and the scientific method. We do not believe in scientism, and, you know, that's really where the mainstream is coming from, and that's a fact, guys, and all you have to do to determine that is use your own common sense and listen to what each side is putting out. So there you have it. So, yeah, I guess that's all I had. You guys have anything?
No, I'm all spent. Look forward to next week, but yeah. FTFF and hashtag test it.
That's right. I agree. All right, cool. So, John, you have anything coming up that you're doing in the next week that you want to highlight for everybody?
Yeah,
John?
the same sort of stuff I've been working on. I'm trying to get stuff out. It's just been a lot of personal things going on, and my attention has not been able to focus on one thing for very long here lately. So yeah, I'm hoping to get a bunch of stuff out, actually. So yeah, just keep a check on the channel, and hopefully you'll get notified whenever I get something up there. But I don't know how good that works for anybody else. But I don't hardly get any notifications on YouTube anymore. So that's where I'm still at for the time being. But no, great show, guys. I had a real good time with you. A lot of fun as always. And as always, thanks to the live listeners and viewers. Love you guys. Thanks so much. And yeah, we'll see you, I guess, Sunday.
All right, cool. And Zach, our newest Globebuster, what do you have coming up?
I'm finally coming out of my funk, so hopefully I'll be getting back into video editing mode here soon. Just need to light that spark under my butt. Yeah, I have a Polaris video that I've been thinking about for over a month now, and how I'm going to do it, and just wording it out in my head. So I think I'm going to hit it kind of like I did my the electrostatic one. I'm going to write it out. It's going to be, you know, a 10-15 minute video, and I'm going to rewrite it and ask people what they think about it and take their info and rewrite it and really nail it down again. I want to start focusing on making not so much as an abundance of content, but really good quality content that people can understand.
Excellent. Yes. And One Raven, no, Glowbusters is not on TikTok. I mean, I know what it is, but I've never done anything on it. So no, we're not on TikTok. We are on several other platforms though. We're on DLive, we're on Library, we're on Odyssey. God, there's a few others. I don't even remember all of them these days. And of course, when and if Lighthouse ever comes online, we'll probably have something there. But I think we're going to keep our mainstream show, our mainline show on Rockfin, because they are definitely treating us the best, and these are some of the best content creators out there. So, and I'm honored to be amongst them, to be honest with you. It's pretty cool. So, and also one other thing, Zach, I got word from Sandor today, who's another member of FE Core, and he is doing an experiment like, we've been waiting to do if we can find a place, but he's actually going to go out tomorrow, and he's got those balls made up with the magnets inside of them, and he's going to do his drop tests. And so we will have that to look forward to and see what his results are, and then hopefully we will be able to replicate them ourselves and just kind of blow this whole gravitational paradigm apart that the mainstream is trying to sell us. So that'll be pretty cool.
Yeah, and about that, if anybody can find a spot to do this drop, I've put questions out to a few different places, and I don't get any real results. If you type my name into Google, flat earth lunacy and all this nonsense comes up, so it could be kind of deterring them from allowing us to do this. I don't know. But if you all can just think of a place, 100-foot drop, preferably a natural, like a stone, overlook a little bit, where you get a nice sheer drop straight down to a place where we can catch it, preferably not over running water or something like that. But yeah, I've never had this much trouble doing, an experiment.
Yeah,
and
it is
yeah,
difficult.
This is starting to eat away at me now.
Yeah, we'll get to it. It'll happen eventually. We may have to just get out and actually start driving around the countryside, if nothing else, but there's got to be a place sufficient. But Sandor found a really good place, so I'm excited to see his results that he comes up with.
Yeah, absolutely.
All right, cool. All right, guys, that will be our show for tonight. Thank you so much for joining us. You are rock stars. For all of you that gave us tips in Rockfin, thank you so much. You really help us out with that. And super chats. I don't know if I saw any super chats coming on YouTube or not, but if you did and I missed it, I apologize. But all of that support is absolutely very much appreciated. And I will get better at shouting those out. That's something that I need to kind of integrate into my console here, is to keep track of those things. And we'll even start taking real live time questions with the super chat, because that seems to be a really good format for people to ask questions. And even though we've never really been too much about answering questions live, I think that's probably a good thing to integrate into the show. And yeah, so we'll do that. So that's it for us. We will see you Sunday. Everybody take care of yourselves. Be good to each other. Don't lie to each other. Open your mind, because